All right. Welcome everyone to JavaScript and Friends Conference 2021. Thank you for joining us today. And if you're watching us live, feel free to join our Slack channel. So without delaying, I will give it over to Brandon. Brandon, welcome to Keynote JavaScript and Friends Conference 2021. Without delay, it is all yours.
Awesome. Thank you so much. Good morning, everyone. It's awesome to be able to kick off the JavaScript and Friends Conference this year. So let's begin by going back in time and taking a look at the first age of full stack React. The journey begins in 2013, the year in which React did not even exist. That is until May 29th, when React was first announced at JSConf US. So that means React is now 8 years old. Isn't that crazy? It seems to me like React is way older. And we look back at this as a very significant event because many of our careers are built around this very thing. But back then, it was not that well received and got a lot of hate. Like people were especially hated JSX, which we now take for granted. Now, I think there were like two kind of key breakthroughs that React brought. And React wasn't necessarily the first to do these, but I think React really popularized it. And the first one is just simply making it easier to build and maintain complex user interfaces. And then secondly is the declarative component model. And this is like really taking the world by storm. Like React is being used in so many places, right? On the web, mobile apps, desktop apps. You can use React to generate PDFs. You can use React to build 3D experiences like in games, like with React 3D Fiber. And so React is just amazing. It's so cool. Now, like I originally got into JavaScript frameworks with Ember, and I learned the basics, was able to do some rudimentary stuff, but it didn't click. And I'm not sure really why that was, but later when I tried React, it just like instantly clicked with how I think about like building UIs and components and things. So they did something right. They got something right. Now, moving on to 2015, the version 0.13 of React was a very significant release because it introduced support for ES6 classes. Now, before this, you had to create a component, you had to use the react.create class method. And many of you may not even know that exists, but that's how you used to create components. And there was these things called mix-ins that are considered harmful, apparently. And anyways, this was like, a big release for React. Now, another thing in 2015 is that at this time, we're pretty much fully in the single page app era where people have separate backends and front ends, and they're doing a lot of JavaScript stuff. And so now the API layer is being used very heavily. And so we needed a new approach that was better suited for front ends than REST APIs. And so Facebook introduced GraphQL and has obviously, gotten a lot of traction and a lot of adoption and use over the years. And so this was introduced in 2015. And I think largely it came about because of React, in building front-end client-side heavy apps. So now we go to the next year, 2016, which was a huge year for React. There were two very significant projects released in 2016. The meta frameworks, Create React App and Next.js, are those two projects. And they were both released within months of each other, which is like, it's like thinking back, it feels like Create React App came before Next.js, but really they were released like very much around the same time. And Create React App was optimized for static single page applications, but at the time, Next.js did not have anything static. It was fully server-side rendered. And so it was like starting on opposite ends of the spectrum, really. Now, before this, you had to know about Webpack to make something just work. And so the big breakthrough here with both of these is that now, for the most part, you don't need to touch Webpack. You don't even really need to know about it necessarily. And so that is a huge step of just like taking that away from you. But Next.js went a step farther and abstracted away the router and introduced automatic per page bundling. And so before this, like you would, even with Create React App, I think still today, you have to manually code split your pages and your bundles. So by default, everything goes in one massive bundle that can like slows down the page and creates UX problems. But Next.js, by default, each page is automatically code split. So that was really awesome. And I think it's really interesting how Next.js has completely surpassed Create React App. You know, Next.js is a fully hybrid framework now that supports basically every single use case. Whereas Create React App has changed very little. It's still pretty much the same thing, doing just static stuff. And so I think a key learning here is that software libraries and frameworks should be built to first to solve the most kind of foundational need. And then you can expand from there. So for example, Next.js started with server-side rendering, not static. And server-side rendering is more foundational than static because static is like a subset of server-side render. It's just a server-side rendering at build time. And so it was much easier for Next.js to expand to support static than it is for Create React App to expand to support server-side rendering. Now, one more thing in 2016 is that we saw the introduction of GraphQL backends as a service. Graph.cool was the first of these, as far as I know, and is no longer around today. In fact, GraphQL is now Prisma. So GraphQL was the very first version of Prisma. And this, and then in 2018, Hasura was released. So you probably have heard about Hasura. They're still around and being used. So this was a super cool concept because it meant you no longer had to build a backend API. You simply define your database schema, and then you would automatically have a GraphQL API generated for you based on that database schema. But as you get experience building apps like this, you begin to realize the downsides and the drawbacks. You are tied to a third-party service, even if you self-host it, and you don't have full control over the API. So it's hard or impossible to customize that API to meet your business requirements. But there's an idea here that is really powerful. And that is the ability to get your backend up quickly without having to know a lot about it or without being a backend developer. We'll come back to this point when we get to Bliss.js. Moving on to 2019. This is when React Hooks was officially released in a stable version at the beginning of the year. So this is just, a little over 2 years ago when Hooks was released, and it has really taken the JavaScript world by storm. And it's pretty much how we all build, components by default these days. And the other thing that was released in 2019 that was a really big deal was the addition of API routes to Next.js. And this is one of the things that totally changed the trajectory of Next.js adoption. Because now, finally, Next.js has the potential to be used for an entire full stack application. But you still had to do everything yourself. So the primitive was there, but it was still very difficult to go further than that. So now here we are at the beginning of 2020. The outlook for full stack React devs is quite bleak, and in fact, the world as well. It's 7 years after React was released, and we still don't have anything remotely comparable to Ruby on Rails or Laravel for JavaScript or React. When starting a new project, you have a million decisions to make about your app architecture. And tooling, you have to configure everything together, make them all work. But even with all the options, like none of them are truly great. And it's hard to make a really nice DX and UX. In fact, a portion of React devs are abandoning React altogether and going back to traditional Rails setup with SSR, with server-side rendering, because they realize that, like, hey, we're more productive with Rails than we are with React. Let's just go back and do that. But then comes February 17th, 2020, and an unknown fellow by the name of Brandon Bear announces a revolutionary full stack framework for React called Blitz.js. React developers all around the world got super excited because finally they would have a solution to their full stack blues. Now, there are two kind of key pillars that holds Blitz up and makes it awesome, and is why people choose Blitz. Number one is that Blitz is a batteries included framework like Rails, like Ruby on Rails or Laravel, but for JavaScript and React. And so it's a puts you into the pit of success, and it does all the menial, like boring stuff for you. And so out of the box, when you create a new app, there's so many things set up: linting, testing, automatic code formatting, like with Prettier. User authentication, login, sign up is already set up for you by default. And so immediately you can start building out your unique features instead of just getting the thing to run and getting, all the basics set up. And then the second big thing with Blitz is the zero API data layer, which we invented and which doesn't exist anywhere else. And what we do is we abstract the API layer into a compile step. And so you, as a developer, all you have to do is write functions that run on the server. And so in that function, you would talk to a database or talk to an API or whatever you need to do on the server. And then you import that server function into your front-end components, your React components, and it just magically works. You don't have to mess with a REST API or a GraphQL API or HTTP or anything. It just automatically works for you. In fact, we handle caching the server data on the client. We do cache and validation, automatic retries, etc. And it's a super nice experience. Like it's mind-blowing when you try it. It's like it breaks something in your head. It's like, wait, what else do I have to do? Like, it can't be this easy. But people literally are telling us that it makes them 5 to 10 times more productive than using any other stacks. Now, Blitz extends Next.js. So Blitz takes Next.js, which is very minimal, and it adds all the full stack power features that you need to really build a full stack application. It removes some of the chains and restrictions that Next.js puts on you, and so it's more powerful and flexible. And then we have all the other features on top. So it's like we've created a distribution, a custom distribution of Next.js. And in fact, we technically are a fork of Next.js now, but we keep up to date with Next.js and merge in all their new features. But 1 month after Blitz was announced, another full stack framework comes on the scene called Redwood.js. Redwood seeks to solve the very same problems as Blitz, making developer experience easier and to be a Ruby on Rails, equivalent. But instead of abstracting away the API like Blitz does, Redwood doubles down on it with GraphQL. And so in many ways, it provides a similar developer experience as those GraphQL backend as a service things like Hasura or GraphQL. But in the case of Redwood, you fully own that API and can customize it however you want. And so that's like a key thing that I really like about Redwood is you get that developer experience, but you have control over that API. And then Blitz and Redwood are very, very similar, and we'll talk about more of those commonalities in just a minute. But just like that, we go from 2013 all the way to 2020 with nothing like this. And then all of a sudden, within about a month, we are fully launched into a new era for full stack React, where we have two frameworks that are like really seeking to solve this problem in two different ways. And so if you don't like one, then you probably will like the other. So let's look at what's common between Blitz and Redwood. They are both full stack JavaScript and TypeScript. So you can choose JavaScript or TypeScript, but it's full stack. Like you don't have to use a different language on the server. You don't have to use like Ruby on Rails on the server or something. It's JavaScript everywhere. And so a lot of people really like that, including myself. Next is that they are both batteries included frameworks like Rails or Laravel. So you get a lot of really kind of cool things that you just simply don't like. So of course, if you don't use Blitz and Redwood today, you're probably going to use Next.js and craft your own kind of full stack setup, right? You have to bring your own authentication and bring all this stuff. And you can get a pretty much equivalent, architectural setup, but there's still a lot of developer experience things that you miss out on. Like Blitz and Redwood have a console, like Blitz console, which is similar to the Rails console. It's a REPL that loads your code and makes it easy to run your code and prototyping and stuff. And Blitz has like, there's just so many nice developer experience things that like you're not going to implement yourself in your own project because it's too much work for kind of too little payoff. But since we're solving it for everyone, we can do that extra work, and then everyone gets all these just really nice things that just like makes you smile throughout your day. Number 3 is a monolithic developer experience. And I am I'm a huge fan of the monolithic developer experience. So a monolith is one thing. It means that like you have one big thing, one thing to think about, one thing to develop, one thing to reason about. It's sort of like all together instead of having all these like random bespoke services that you kind of have to orchestrate and keep track of. And so Blitz and Redwood both give you a nice, monolithic DX. But what's interesting is that you can deploy it as not a monolith. So Blitz, you can deploy serverless, where each of your endpoints is a independent serverless function. And then Redwood has a similar thing. You can deploy your front end, back end separately. So it's still like monoliths get a bad rap by some people. And so this is what we call more like, it's like a modern monolith. So you have a lot of the benefits, but without a lot of the downsides historically. And then 4 is that both of these are opinionated frameworks. So they have some opinions about recommendations on how to structure your code, how to do things. And, for the most part, Blitz doesn't enforce a lot of those. Blitz is, we call it loose opinions, but it gives you enough opinions to put you into the pit of success. And then lastly is that they really focus on full stack, not just front end or back end, but really focus on the whole end-to-end full stack productivity. So let's do a Blitz demo, shall we? All right, so here we are in the terminal, and I have just created a brand new Blitz app. So I installed the Blitz CLI. It's like yarn global add Blitz or npm -i-g Blitz. And then you can run the Blitz CLI and run Blitz new. In this case, I said JS friends. And you can see it generates a lot of files for you. So initially, this can be a little bit overwhelming because there's so much here. But what we're optimizing for is actually getting real work done, not just impressive, like super minimal demos, right? That's like, oh, this is so easy. There's only 2 files, but then what, So we have, most of this is like, or a good chunk of it is authentication. So this is login form, sign up form, and you can go in there and fully customize it. So some of this we could abstract away, but we decided not to because we want to give you ownership over that code so that you can customize it for your business requirements. Okay, and so it already installed dependencies. It already set up an SQLite database for you, and then already initialized your Git repo. Okay, so we're inside the thing and we're going to run blitz dev, and this is going to start the server, and it's compiling. Okay, so now we are going to load this page and see what we get. So of course it's extra slow because I'm streaming. It's usually faster for most people. All right, so this is just a very basic, the starting page, default starting page, and you can see there's a sign up and a login button. So let's go ahead and sign up with the user. And now you can see that I'm already signed up. So I just created the new app. I haven't touched the code. I haven't even opened my editor yet. And I already can log in, log out, forgot password, all that's already set up for you, which is super cool. It's one of my favorite things about Blitz. Okay. So now what I want to do is I'm going to create a new thing called a project model. So we're going to kill the server and we're going to run blitz generate all project. And so it's going to generate a project model, and we're going to give it a name attribute, which is a string. So this will create a number of files. This was sort of a glitch. That shouldn't be right there. Not sure what happened, but anyways, so it creates a number of files for you. So this is everything you need end to end to create, read, update, delete. So this is like all your fundamental CRUD operations, everything you need. So it has all the pages. So a page to view a list of projects, to create a project, to view a single project, and then to edit that one. And then it has a form, and then it has your two queries to get one or get many projects, and then your mutations for create, update, and delete. And then lastly, it adds the project to your database schema. So it has an ID field, it created that, updated that, in a name field. Now this is super cool because it's already, like you can see, it's full stack, all the way, everything end to end from front end to the database. All right, it's asking if we want to update the database. So I will say yes. Give it a name. All right, now we'll go ahead and start that. And while it's starting, I'm going to go and open up the Prisma schema file. So this is sort of like your very, very base layer, right? When you have an application, is what your database is. So in here, most of this is what you get by default. A user model, a session model, a token model, all comes with Blitz by default. And you can see it's pretty much straight, like a self-explanatory syntax. You have the fields and the types. And then you can have relationships. So a user has many tokens, a user has many sessions. And then down here at the bottom, you can see that we have a new project model. Okay, so let's go back to our page, and we're going to go to /projects. And look, we already have a list of projects. Now there's nothing in the database yet, so it's an empty list. But we can click create project, and it takes us to /projects/new. And we'll call this keynote presentation, and click create, and boom, we now have a project in our database. We're viewing that at project/1. You can see that we're loading all the data, and so it's ready for you to kind of customize and display it however you want. So that's really cool, huh? So we could delete that, we could edit it, and it takes you back, and we could add an exclamation point, update, takes you right back, and it's like, it's all there. click create projects, you can see the list of projects. So that's super cool. Now, let me show you another trick. You can run Blitz Prisma Studio, and this is going to do something really cool. It's going to open up a graphical user interface for your database. So here you can see all the models in your database: project, session, token, user. So let's look at projects, and you can see all the data for all of those things. So ID, created that, updated that, name. So let's just like add a bunch of exclamation points. We're going to save that. And so that updated in the database. Now, notice that it was one exclamation, and now there's two more. So if I click back over here, look, it automatically updated as soon as I came over here because of how we like automatically handle the refetching and caching and stuff. So it's just amazing. It gets me so excited about like how awesome it is. So hopefully you find it awesome too. All right, let's look at some more code. So let's go look at the project page. So this is the code for viewing a single project. Now, this is a normal React component here. We have some hooks. We get project ID from the URL, and then we have a use query hook. So this is something that Blitz provides you. Use query, and then you pass it a get project query function, which we'll look at in a minute. So you pass it that function, and then the arguments for that function, which is a specific ID. And then this hook will return a project. And we can, and then this project we can render out. So we have project ID, put that in the title, and then we JSON stringify like the whole thing. That's what you're seeing, just like by default. So this is all it is on the front end, right? So there's no HTTP, no Redux, no GraphQL, none of that. It's just this use query hook and pass it this function, and it just magically works. So let's go look at this thing right here. Okay, so this is right here is that function. Okay, so this is all it is end to end. This file and this other file. Go back. It's just those two files. So in here, I'm going to reformat this slightly to make it a little bit more easier to see. So this is a query function. It's a standard interface, which is just it's a function that takes two arguments. Resolver.pipe is it's a utility that makes it a lot nicer. But really what this is export default. You have input and context, and then you return a result. So the first argument is your input, which you go back over here to the client. That's this ID object. So that's what's going to come in as the input. And then the context is added by Blitz. And this includes stuff like authentication and the other things that you can actually add to it if you want. And then you return the result. And whatever you return is going to come out here on the client. So inside this default setup, the first thing we do is call resolver.zod. And this parses your input and it ensures that your input is valid and has the expected fields and types. And the next thing is we call resolver.authorize. And so this is how you make sure a user is logged in. So if this line is here and you're not logged in, you're going to get an error page. And then we could also do specify a certain role, like we could say admin. And then if you don't have the admin role, then it's going to throw an authorization error. So Blitz has all this built in for you. So right here, this is like where the real business logic is. And so we're not doing too much here, but we call database.project.find first, where the ID is equal to the ID that you passed in. Now this is Prisma 2. This database object comes from Prisma. So you don't have to use Prisma with Blitz. You can remove Prisma and use something like TypeORM or Mongo or like something else. Actually, Prisma supports Mongo now. But we think Prisma is best for most people. So we're going to get this project from the database, and you can see that this is something really cool about Prisma is that it's fully typed. So you can say project dot, and you can see all the fields on that thing. Isn't that cool? ID, name, created dot, you can see the types, etc. And then, so if it doesn't exist, we're going to say, hey, let's just throw a not found error, and then we'll return this thing. So we'll go back to the client and check this out. Project dot, and all the fields are auto-completed on the client as well. And so there's no like code generation process that's running in the background to do this. It's just all there statically. And this is one of my other favorite things about Blitz is that you get end-to-end type safety and auto completion all the way across your entire stack just by default. Okay. So something else to note here is that we automatically serialize and deserialize dates, maps, sets, and things like that. So if you've used APIs, I'm sure you've had to deal with dates, right? So an API comes across the wire, or a date comes across a wire as a string, and then you have to convert it to a date to be able to, manipulate it if you want to. So we automatically do that for you. So if you return a date on the server, which in this case, this project model has a date created on it, we will automatically serialize and deserialize that. So when it gets out here, created at is also a date. And we built a custom library to do this called Super JSON. And it is super cool because I hate serializing dates. I'm sure you do too. So you don't have to ever do that again. All right, error handling. So error handling is something that is super cool in Blitz as well. So you know the try catch model, right? That's how you handle errors in JavaScript is you throw an error and then you have a try catch to catch that. So we take that model and we extend it across the full stack. So it allows you to throw an error on the server and then catch it in the front end. Okay, so you throw an error on the server and then you can catch it on the front end. So in this case, we are throwing a not found error here, and then also this authorize inside of that, the internal code for authorize will throw a authorization error. So it's the same thing, it just throws an error. So how do we catch errors in React? Anybody know? I wish I was in person so I could, see your hands or something. But anyone know how to catch an error in React? You use an error boundary component. So an error boundary component is how you catch errors. And we already have an error boundary set up for you in the very root of your application, which is the _app page. And right here is this app component. This is the very root of your application. And here is the error boundary component. And so this is the try catch for React. And so this will catch your error. And then right here is how we render it. So by default, we say, hey, if this error is an instance of authentication error, then just show them a login form so they can log in and get on with their day. If it's an authorization error, we say, hey, you're not authorized. Otherwise, we just kind of default to the standard, whatever the error status code is. And so in the case of not found error, it's going to render this thing and it's going to show like a 404 page. Okay, so that's error handling. Now, let's take a look at the CLI and some of the other really cool things we have. We have a thing called recipes. So if you want to install a third-party dependency, like let's say Chakra UI for your styling, you can run blitz install Chakra UI, and it will automatically install all the dependencies that you need. It'll automatically set up all the config files, and it will automatically add the theme provider to your application. And so you basically don't even have to look at the docs on how to install libraries. So we have quite a few, but not a lot recipes. But we're looking to make it easier to add more recipes. And of course, anyone is welcome to contribute recipes. So it's probably a bit slow because I'm streaming here and stuff, but it will download that and install Chakra and set it up automatically for you. The other thing that Blitz has is this, I mentioned it earlier, is Blitz console. And so you type Blitz console and it opens up this node REPL that allows you to just easily access your database and things. This is also a bit slow. It's something we're going to optimize. So, all right. So here I can just write, code like console.log. Hello. All right. So now let's just access the database. Await db.users.findMany. Oops, I misspelled it. It's user singular. There we go. And so I can just run code directly against the database and I can see this. So let's update my name, update user dot update where ID is equal to 1. And then data is going to be name Brandon. All right. And there we did. We just updated, we just ran a command against the database. And so you can actually connect to your production database, using the same way. And that's really handy for debugging production issues and fixing things if you need. Okay. So I think that is all I have to show you for this demo. Now let's get back to the presentation for the final section. All right. So here we are. We've had 8 years of React. We're at the beginning of a new era with Blitz and Redwood. What to look forward to? Number one is that it's going to continue to get easier than ever for front-end developers to do full stack. And this is something I hear from a lot of people using Blitz, is that they can hire front-end developers to do full stack work because Blitz makes full stack so easy. Secondly, is increasing productivity for full stack developers. So this is a game changer for solo teams, small teams, and also large teams, because you can get just so much faster feature velocity. You're more motivated and productive because you're not wasting time on dumb stuff. And so this is just going to continue to increase. Thirdly is more advanced backend architecture and patterns, and making them much more accessible to more people. So background processing, queues, scheduled jobs, sending emails, file uploads, all of these things are like pretty much essential for any type of application. And so Blitz, Redwood, and also other services and open source projects that are being worked on and that will come out yet. They're just going to make these easier and more accessible to more people. And number 4 is serverless. Serverless, by and large, is still sort of the Wild West. There's, it's been battle tested, but yet it's still difficult to use and make everything just really hum like you want it to. And so I think there's going to be, massive developer experience things coming for serverless. And also, I think it's important for us to recognize that serverless does not necessarily mean serverless functions. To me, serverless means that you don't have to worry about individual servers. You don't have to worry about like patching, logging in, updating the operating system. You don't have to worry about like it just like some service like just handles it for you. So even if it's a long running process, it can still, have a serverless feel where you don't have to worry about it. It's already automatically managed for you. All right. And number 5 is mobile apps being integrated into the full stack developer experience. So once we get to 1.0, after 1.0 for Blitz, Blitz is almost a 1.0. And after that point, we're going to look at bringing first class support to React Native. And so this will make it really easy to use your Blitz backend from mobile apps. So some people are doing that already, but we really want to make that a much nicer experience. Now, there is one more thing I'm super excited about that is really going to change the game for deploying full stack apps. Heroku has been amazing, but Heroku is Heroku. And it is time for a next generation deployment platform, one that brings a breakthrough level of developer experience to deploying full stack apps. And that next generation deployment platform is called Flight Control. Flight Control is a brand new company I just announced a few weeks ago, and you can think of it like a next generation Heroku. These three things are the key ingredients to make a really awesome next generation deployment platform, and Flight Control includes all of these. So number one, it runs on your own cloud, which is really important for doing backend or full stack, because you want to have full control and insight into what's actually happening with your servers or your serverless functions. And then you also want to be able to use Amazon services like DynamoDB or SQS. And so we allow you to do that. And then also we make it easy for you as well. Secondly, is being highly optimized for specific frameworks. This allows the platform to provide a really next level developer experience where things it's just a really magical integration. It just works really nice. So we're doing that starting with Blitz and Next.js. So Flight Control initially is optimized for Blitz and Next.js. And then thirdly is supporting both containers and serverless functions. And this is really important because it's not a one-size-fits-all solution. And you need to be able to switch between those like as you grow. So when you're small, maybe one is cheaper than the other. But as you grow, then you need to switch for cost or performance. And so Flight Control makes it easy to switch between these without changing any code. And that's both for hosting and for background processing. So if that sounds interesting to you, go to flightcontrol.dev and put in your email and join our wait list. And we should be launching our MVP later this year. And that concludes my presentation for this morning. If you would like to keep up to date with me, you can follow me on Twitter at Flybear, FLYBAYER. If you are interested in learning more about Blitz.js, go to blitzjs.com and we have all the documentation. We have everything you need there. And then last but not least, if you want free stickers, go to blitzjs.com/stickers, enter your address, and we will mail you 3 free Blitz.js stickers. So thank you so much for your attention today, and I hope you have an awesome rest of the conference.
Awesome. Thanks, Brian. Thanks for giving us a wonderful overview about Blitz.js and what you have been doing over there, and with your recent edition about Flight Control. So we are excited about your work. So thank you for keynoting JavaScript and Friends Conference 2021. Friends, if you are following along the talk, you can always meet with Brandon in our Slack workspace. If you have any follow-up questions, you can meet him over there, or as Brandon mentioned, you can always reach out to him on Twitter. Feel free to use our hashtags JSFriendsConf 2021, and we are excited for this year and hope we make next year in person. Thank you all, and enjoy the rest of the conference. And thanks, Brandon. Thanks for speaking.
Yep. Thank you. Bye.
Okay, it looks like I'm live. I'm waiting for the lag to catch up, by the way, if you're wondering why I'm pausing awkwardly, people who are watching. I see myself now, so the lag is truly and finally been overcome. So I got about 2 minutes before we get started here, so just hang tight.
Sure.
You want to interact with me, people out there on in internet land, drop a message in Slack.
Yeah.
In track 1 questions, which is we're on track 1, right?
Right.
I am watching YouTube as well, so if you happen to be on YouTube and you want to drop a message there, I will see it. But Slack is the preferred channel, so go join the Slack, and if you're not in there already, and all that. It looks like there's a lag of about 30 seconds. So if I see your question, there may be a little bit of a delay. Well, it should be about a 30-second delay for me to respond to it, assuming I respond immediately, which maybe I won't. Maybe your question won't be good enough to justify an immediate response, in which case I will politely ignore. I will respond to all of your questions. Cool. And know that if I'm looking over here, it's that I'm looking at my screen. I'm still looking at you all. Don't worry. Got about a minute to go here. I've actually broken a rule today. I have not rehearsed this before I'm giving this talk, but I just gave this talk yesterday morning at Codepalooza, and I rehearsed it for that. So I should be good. But if I am particularly fumbly this morning, then that's because I am not as bright-eyed and bushy-tailed as I may look. You're very welcome, Elliot. Happy to do it. So, well, we're at 9:30 a.m. I've got a full hour, correct, Bhaskar? Or do I have 45 minutes? I can't remember. Probably an important detail. Drop it in chat and let me know. I'm going to go ahead and get started here. So welcome, everyone. This is Finding Bigfoot with Redis and RediSearch. Yeah, it's a Bigfoot themed talk. I know, shocking coming from me, right? My name is Guy Royse. I'm a developer advocate at Redis. There are 3 things on this slide that matter or that are worth pointing out. The first thing is something my boss wants you to see. The second thing is something that I want you to see. And the third thing is the thing that you probably actually care about. The first thing, the thing that my boss wants you to see is that nice, bright, shiny red Redis logo there. I work for Redis. Redis builds a lot of fantastic, in-memory database products, Redis, and lots of modules that extend it, including RediSearch, which we're going to talk about today. And so we want you to go check out our stuff. So please go check out our stuff and make my boss happy. The thing that I want you to see is my Twitter ID right here. I'm at Guy Royse on Twitter. And, I judge my sense of personal accomplishment and worth based on the number of Twitter followers that I have. So please give me a follow on Twitter. And if you like this talk while I'm giving it, go ahead and mention me on Twitter as well. And the thing that you actually care about, the rest of this is just, vainglorious stuff, is the github.com/Guy Royse link there. So all the code and the slides and everything that I'm presenting today will all be available out there on github.com/Guy Royse. So go check that out there. And if you want to read an outdated blog, you can go to guy.dev. So Bigfoot. This is a very big footprint, right? Bigfoot is a thing that's always sort of captured. I don't know. There's just something compelling about it to me. There's something about this large, hairy hominid hanging out in the woods that's just, feels familiar and comforting and something that I could really relate to. And there's something fun about the mystery of it. It's, Bigfoot, he's out there, but, no one, the photos we've got are blurry. There's sketches and that kind of stuff. And it's, there's a compelling mystery there, but probably the real reason that I like Bigfoot is not the mystery, and it's not the physical resemblance to Bigfoot that I have. It's that Bigfoot was my father. And I actually have a non-blurry photo of my father. Very few people have these. but I have one. And this is the only photo I have of my dad. He went out, he disappeared years ago when I was a kid. He went out to get milk and cigarettes and never came back. And I miss my dad, and I'm trying to find him, but he's hard to find. He's been hiding in the woods. And so I'm on a quest to find Bigfoot, to find my father. I started my quest. I thought, well, let's do some research, right? That's a good place to start. Let's do some research, and let's hit the stacks. Let's go to the libraries, look at the periodicals, and try and find, sightings of Bigfoot that make the news. And so I found this particular one here. Dozens of witnesses have seen Bigfoot roaming the wilds with a human child. Well, this is actually me. That's a picture of me when I was about 10 years old, wearing my whitey tidies, running through the woods with my dad. We just stolen a bunch of food from some backpackers, and it was a good day. It was a really good day. Those energy bars, the granola bars they had were delicious. There's lots of stories like this that I found, particularly in Weekly World News, that bastion of quality journalism. It was kind of a nice trip down memory lane, but it didn't actually help me find my father. It talked about things that I already knew about, things that had happened, about the past, but not the present. I wasn't able to find anything current on Bigfoot in the periodicals. So I thought, well, maybe I should go to people who are actively trying to find Bigfoot now and solicit their help. And so I went to the fine folks at the Discovery Channel and asked them for their assistance. And it turns out they don't always find Bigfoot, but when they do, they don't. And I actually, and as an aside, I love this photo because they've sort of set it up, the show, as you've got three true believers and a skeptic. And if you look at this picture, it's kind of obvious who the skeptic is. You can tell by the look on her face. She is very much a Scully to their Mulder. And she's got this look on her face that just says, my God, what have I done with my career? So I hope it's working out for you. This picture's is a few years old, so I'm sure that things have changed a little bit, but they weren't able to help me find Bigfoot either. They weren't even able to find Bigfoot for themselves. And so I thought, well, what am I going to do next? And the guy, I think it's the guy on the right, he's actually the founder of an organization called the Bigfoot Field Researchers Organization. They were founded in 1995, and if you take a look at the screenshot from their website, it's kind of obvious that they were founded in 1995. It totally looks it. And they are purported, they bill themselves as the only scientific research organization exploring the Bigfoot Sasquatch mystery. And more importantly, they have a comprehensive sightings database. I'm like, databases, score. I'm a developer. I can use a database. Except it turns out it wasn't actually a database. It's more of a website just full of reports written for humans to read. So, it's like you'd have a section on what the eyewitness account, it's just regular text. And there's some data fields in there, but they're not consistently applied. And so you could think of it as like a collection of documents, like maybe a bunch of Word documents. And so this isn't exactly in a format that I could use to search. I could go through and click through all the articles, but in a lot of ways, that's no different than looking through the periodicals. But fortunately, Tim Renner came along and he screen scrapes these sites with weird data and creates CSV files. So he has screen scraped the Bigfoot Field Researchers Organization's website, the BFROs, the BFROs website, and turned that into a big pile of useful data. 4,586 sightings throughout the 20th century, all put together in this one little handy CSV file. He's done it for other data sets as well. He's got the Haunted Places Index. He's got a bunch of UFO sightings, and it's just glorious, glorious data. And I'm always so grateful that he did this. And, I always make a point to thank him for it personally. Well, not personally, I've never actually met him in person, but we've talked online. And I am, if you're listening, Tim, very grateful for you doing this once again. And he screen scraped this to do machine learning and data science type stuff against it. He's got some blog posts where he's come to some conclusions about it. Like he used clustering against the Bigfoot sightings to determine that if you find the natural groupings of Bigfoot sightings, it tends to align with Well, it tells you that you can find Bigfoot in the woods. So that's a conclusion. I kind of knew that. The UFO sightings, he discovered that you tended to see UFO sightings within 50 miles of US air bases. And you tended to see them on the 4th of July. So lots of delightful, lots of effort poured into telling us something that we already knew, right? So that's the data that we have. I'm like, I can use this data and I can load it in and I can start doing some actual searching with it. So the data itself is pretty basic. We've got a report ID. This is the ID of the reports, the ID for the humans really, but also for the computers. And so like this is report ID number 8086. Picked it because I knew I would be able to remember the number 8086. It's got a date in ISO 8601 format. It's got a title. This is sort of a, Bigfoot sighting number 8086. A series of large human footprints are found on a farm near Wayne National Forest. You've got the observed. This is the eyewitness account, a full text account of everything that happened, quite large in some cases. So this is the people telling their story. You've got a classification for your Bigfoot sighting. Bigfoot sightings have 3 classifications. There is the Class A Bigfoot sighting, the Class B Bigfoot sighting, and the Class C Bigfoot sighting. Class A is, I saw Bigfoot. Class B is, I found evidence of Bigfoot, like a footprint, or maybe I heard some noises in the night. And Class C is, I heard a story that someone saw Bigfoot. So it's a legend. It's clearly the most reliable of all the Bigfoot sightings. Get your county and state that it occurred in. You've got your latitude and longitude it occurred at. And you've got some location details. And again, this is free form text describing how to get to the place where the sighting occurred. So here, closest town is this, closest main road is this, turn right on here, that kind of stuff. And so this is the data we have to work with. Tim mixed in dark skies weather data using the date and time, or the date, and the location if he had that information. And so we also have all kinds of temperature data associated with it. So we might be able to say, is Bigfoot sightings tend to happen during a full moon, or when it's snowing versus not, that sort of thing. So glorious, glorious data. And we're going to take all this data, and of course, we're going to store it in Redis. And so if you've used Redis before, then I'm going to tell you a little bit you might know already. But if you haven't used Redis, I've got just one little slide here. I'm going to talk about it. Redis, you can think of as a, all those data structures you learned about in data structure class, your hashes, your sets, your linked lists, just even strings. Those are all things that you can create in Redis in like a big hash table. So Redis maintains a large hash table full of other data structures. And then it puts a wire protocol in front of it. So it puts it on the network. And so it becomes a little server that you can interact with to say, store hashes or store sets or store strings or store lists or sorted sets and all kinds of data structures. Popular ones are strings. We could represent our Bigfoot sighting in Redis using strings. And in this case, strings means blobs of binary data that may or may not be text encoded or not. So in our case here, all of our examples here are, I'm doing a little set here where I'm setting the Bigfoot sighting classification. So here's a key, set this key in the giant hash table that is everything that is Redis of Bigfoot : sightings : sighting number 8086 and classification of Class B, set the state to Ohio, and then you can use get to go get it. So these commands are going over that wire protocol. We can store lists in there, linked lists, doubly linked lists. And then you can push and pop to those lists. So maybe we've got a list with all of our new Bigfoot sightings that we need to process, just like the eyewitness account. And we can push and pop to those lists. These make good queues, actually. You've got sets, which are, that set thing, that Venn diagram thing where, there's unique items in the set. There's no duplicates, that sort of thing. And so here we might have a list of all our Bigfoot sightings for a particular state that reference, that report number. So we can use the sadd, the sad command, the saddest of all Redis commands, to add things to a set. And so maybe we've got like state of Ohio and a state of Kentucky, the IDs. And then we can ask, we can use the set is member, the sysmember command to pull those out to see if they exist in there or not. And probably one of the most commonly used structures is the hash. So Redis is a big hash in memory, and then you might want to put hashes in that hash. So this is a hash table. A hash table, well, here we're setting the hash table in the key of Bigfoot : sightings : 8086. That's the key that contains our hash. That hash has a field of classification, and then we set class B. So we call hset and those things there. Hset, the state is Ohio, and then to get things out, we can call hget. So those are simple data ways that we could represent our Bigfoot data in Redis, or really any data. We're going to use primarily hashes to store our data in Redis. Hashes can be thought of as, in a lot of ways, can be treated like documents or records in a data set. So it's got a unique ID that's embedded in the key name 8086 there, and then it's got keys and values that represent all the columns, if you will, or all the fields on that document or in that hash. And so a lot of our data is sparsely populated. There are missing values, and so hashes will work just fine for that. It handles missing values just peachily. So that's great. So we can load all of our Bigfoot sightings into Redis as a hash. And actually, I've got a little demo of this. I'm going to go ahead and hop over here. So let me go ahead and get my Redis up and running. Docker compose up. That gets my Redis instance running. And so this is the sample code here. I've got a little Docker compose YAML to launch Redis here locally. You can install Redis yourself using these images, or you can get a cloud account. There's lots of ways to get this up and running. You'll notice I got RediSearch and RedisJSON, which are modules that extend Redis here. We'll talk about those later, but I've just got Redis up and running. And then I've wrote a little bit of code to load my sightings. If we look here, this is my sightings data. It's a big CSV file with 4,586 records. It goes to 87, but there's a header. So, and these are just all the sightings. And I wrote a little script here, which uses IO Redis to talk to Redis. This is written in Node. This is JavaScript and friends, after all. And I use a little library called CSV parser, which reads my CSV file. I loop through it and basically pull out all the fields. And the main thing here is I'm calling hset, which is setting things in a hash to a key and a value. And if I go ahead and npm run load here, I need to do npm use here first. This is going to go through and load my little database. It's done. And if we go into Redis Insight here, a little tool that allows us to look at Redis, we can connect to our database. We hit the browser and see, hey, there's all our keys. So we click on one. Oh, that one didn't work. There's a new version of this come out. There's a couple of bugs in this particular library. So here we can see there's our ID, our location, our title, our observed. Well, this is going to sound strange, but every story starts great, right? Yeah, Jake, the links for all this stuff are in my slides, and I'll drop them in chat as well. Not a problem. And I've got a slide dedicated. There's even a QR code that you'll be able to scan to get the links to all this stuff. So, that totally works. So, these are these hashes I've loaded. If I want to use like just the straight up Redis CLI, like I can do Bigfoot sighting 160 here. I can say hget all Bigfoot sighting 160. And here we've got a date, a title, an ID. The date and title are missing. There's an ID classification. So this is sparsely populated, but there it is. So that's, loading in all these hashes. And once these are all loaded in, we can kind of, we've got one way to find them already, right? We can look them up by the ID because our key name that we used in Redis has the ID embedded in it. So this sort of acts as a namespace. These are Bigfoot sightings as opposed to, say, UFO sightings or ghost sightings. And this is the ID. And so we could build a simple app that uses Redis, and someone wants to say, I want to report 8086, and then we'll build this key, and then we can call hgetAll from our JavaScript code and then put it on the screen. And so that's useful. But it's kind of limiting. I can only get them by ID. And lots of times you don't know the ID. It's not searching, it's not finding, it's just looking up a thing that I know is there already. And so what if I want to say, find all the Bigfoot sightings that are in Ohio, or all the Class B Bigfoot sightings? Well, I can make and manage my own indexes using sets. A set could be contain an ID, it contain the ID of all the Bigfoot sightings, say in the state of Ohio, or all the Class B sightings. And then if we wanted to look them up, and we could just go get the members of that set. So once we have these sets created, we can call S members, or S members, as I like to say it. And it will return all the members of that key. Boom, got them. So now I've got all the Bigfoot sightings in Ohio. But what if I want to do something a little more interesting? What if I want, like, say, all the Bigfoot sightings in Ohio and Kentucky? Well, there's an SUnion command. We can do a union of a couple sets, and then it will return all the keys that they have between them. I like to pronounce this one as Sun Ion, since that's what it's spelled. That's how it's spelled. But so you can use SUnion to join a couple together. What if you want to do something like, I want all the Class B Bigfoot sightings in Ohio? Well, you can do that as well by using an intersection, sinter. That will give you an intersection of two sets. And so this would give you just Ohio and Class B. So you could build these sets and access, narrow down what you want. And these are pretty good, but they are limited. One aspect that limits them is just that they're prolific, right? I've got 99 problems. Indices is one of them. Apparently having Jonathan Mills in a slide here is also one of them. I like to pick on Jonathan. I'm actually very grateful for permission to use that photo. So what happens, these indices are, well, you got to maintain them, right? If you've got a big static pile of data, this isn't a big deal. But if you've got dynamic data that's changing over time, this is an enormously big deal. So if I go in and say set Bigfoot sighting 8086, turns out it's not Ohio, it's Kentucky. Turns out it's not Class B, it's Class A. Then I need to go through and remove 8086 from Ohio, add it to Kentucky, remove it from Class B, add it to Class A. And in addition to having to maintain these, you've got to maintain a lot of them. Like these can, for states, you end up with 50, right? You have 50 indices, one for each state. For classifications, you've got all three classifications. And, for lots of other fields you might care about, you've got lots of other indices. And so you could be maintaining hundreds and hundreds or thousands even of these indices. So that's kind of a pain. But there's a more insidious problem. And that's that these commands I've just sent in aren't atomic, right? They're individually atomic because Redis is, any individual command in Redis is atomic, but they're not, they need to be part of a transaction. So if I go in and change citing 8086 to be Kentucky and Class A, and then someone immediately comes in and says, give me all the Bigfoot sightings for Ohio, the index hasn't been updated yet. And so they're going to get something that's in Kentucky, but it still is indexed to be in Ohio because there's a race condition. And there are ways to solve this. You can use multi transactions in Redis, and you can watch variables and stuff like that, watch keys. But it uses optimistic locking. And then if someone modifies this while you're busy looking at modifying these things or touches them, it will invalidate your transaction, have to do retries, and the complexity starts spiraling out of control. And so that's a problem. The other problem is that these indices are limited, right? I mean, I can handle simple things like give me all the Bigfoot sightings that are in Kentucky and Ohio. I can just do that with a union, right? I can just union those two sets. But what if I wanted to find, in addition to that, all the Bigfoot sightings in Ohio and Kentucky that were Class A only? How do I do that? I can't daisy chain these commands. I can't do a union or do an intersection on class B and then call union and then pass in Ohio, Kentucky. I could, do a union store of the two fields I care about, and then create a new field. And then with that temporary set, I could then do the intersection with the B, but now I've got a set I got to delete, and now I'm doing multiple operations and they're not atomic. And so it's getting complicated again, right? And what if in addition to class B and in Ohio and Kentucky, I wanted to get Bigfoot sightings where the temperature was greater than 75 degrees? How do I build a set to handle that? Do I build a set for 75 or greater, 76 or greater, 77 or greater? These indices get big quickly. I'm not sure how I would do that in a realistic way. And what if I want to say I want to find all the Bigfoot sightings that have the word creek in them, in like the description or in the title? And what if I want to get all the Bigfoot sightings that are within 50 miles of Cincinnati? How the hell do I do these things? I don't know. Well, actually, I do know, because this is a rhetorical question. And of course, the answer to this is the other half of our topic. We've been talking about Redis and how to store data and find data in it. But we haven't talked about RediSearch yet. And RediSearch is the way you solve this problem. RediSearch is a module for Redis. It extends Redis. Modules extend Redis. We've got search. There's AI. There's lots of ones that Redis creates. There's ones that are out there in open source from other people. Get everything from Redis Gears, which lets you run arbitrary Python code in your Redis server, Redis AI to do AI modeling. We got Redis JSON to let you store JSON documents. There's lots and lots of modules that do lots and lots of things. RediSearch adds indexing, the problem we've just been talking about, full text search. So I can take these big blobs of text and say, you want to find me all the Bigfoot sightings that have the word creek in them. And aggregation. So I can go over data in Redis and aggregate together, grouping it by particular fields. And it can do this against hashes and against JSON documents. And we're going to show hashes in this talk. But RediSearch adds all these capabilities. So it gives me everything that I want and a little bit more. To create an index, once we have RediSearch up and running, we use the ft-create command. We give the index a name. We tell it the type of field we want to do an index on. So you can do hashes, and you can use JSON right now. We're using hashes. We tell the index that monitor any keys that start with this prefix. So if it starts with Bigfoot : sighting : then, and it's a hash, then pay attention to changes to it so that we can update the index. And it does that automatically. When you change a hash that has that prefix, the index gets updated as part of that operation. And then we define the schema for what we want to search, because you could have lots of columns or lots of fields in your hash, but you don't necessarily want to index them all. They might not matter. And so you can say, for example, you provide your field name in the hash that you want to index, provide the type of it, get text, tag, numeric, and geo. And I'll go into those more in a bit. And whether you want to sort on that column or not, or if you just want to use the score, the page ranking, the scoring of the full text search. And so usually you want to mark them sortable because it gives you an option. The real trade-off here is if you mark it sortable, your index is going to be bigger. If you don't mark it sortable, it's going to be smaller. But then the sortable makes it faster at runtime. So you're making a performance trade-off there. Usually you want to mark it sortable. Usually speed is more important than space, but that's not always true. The simplest search query for RediSearch will return everything. And so this little command here is ft-search. We give it an index. That's the index that we created just in the previous command. And we can give it a query. That'd be what we want to search for. Star returns everything. Shocking, I know. And yeah, that's it, right? You'll notice that I've got it in quotes there. Strictly speaking, you don't need quotes to search for everything. You just pass in a star, but your queries almost invariably end up with white space in them. So quotes are a good practice. In addition to adding to just searching for an index for a query string, you can put limits on it where you can say, I want to start at result 0 and give me 3 results, or I want to start at result 100 and give me 20 of them, or whatever you want. And you can say, return the data that you found, but I don't want everything. I just want these 2 fields. return ID and state. And that little 2 there is the saying that there's 2 fields I want returned. If I wanted ID, state, and title, then I would have put a 3 there. And so this is the most basic of searches. And what it returns is this structure from Redis. It returns first the number of sightings that were matched by that query, 4,586. It returns the keys and values. So this is the key for a Bigfoot sighting that matches. And then it's got all the values in that hash, the key and all the values in the hash, the key and all the values in the hash. And it's only returning the values in that hash that you've asked for. You can actually set the return 0, and then it will not return the hashes. It will only return the keys. So lines 3, 5, and 7 would be removed. And you can even say limit 0, 0, which says don't return any results, and you'll just get the count back. So there's a lot of interesting little shortcuts that you can do here. I just want to know how many things match this query. That's a quick way to do it. I mentioned there are 4 ways to find Bigfoot. We got text. That is full text search. Find Bigfoot sightings that have the word creek in them. We've got tags. That is sort of like a string value or an ID value. You can think of it as sort of like an enum or unique ID. Tags can also be comma separated. So you can think of them as like a tag cloud. Like my blog post is tagged with Bigfoot and Redis and weird. And if you have a field that's got comma separated values in them, like you can have Ohio, comma Kentucky, comma West Virginia, then those tags would match Ohio or Kentucky or West Virginia. You got numeric, which are numbers, and you got geo, which is a geolocation field, lets you do geo searches. And I'm actually, let me check here really quick. Do I have a full hour or do I have 45 minutes? Because I've got 15 minutes left to go if I've got 45 minutes. And so I'm going to check my calendar here really quick because I've forgotten. I've got a full hour. So good. You guys are stuck with me for another 30 minutes. So let's look at how text searches work. So here I've done a simple create. This looks like the create I did earlier. To make it text, you give it the type of text. And so the title and the observed are 2 popular text fields that we might want to do full text searching on. To actually query it, we do FT search again, and our query is just the word that we want to search for. If we just look for creek, that'll find all the Bigfoot sightings that have the word creek in them. If we want to do creek and another word, we just put the other word. So this would only find things that were creek and river. You can also do a or an optional. So creek and then a little tilde there would say creek has to be there. If river's there, that will score higher. If river's not there, it will score lower. So you can do sort of an optional search. You can use an or. So find anything has creek or river or both. You can use parentheses to make this, more complex. So you can say creek or river and stream. And you can say creek or river and not stream by putting a little dash there that negates it. You can just say, give me every Bigfoot sighting that doesn't have the word stream in it as well. That works. And if you want to be specific about your columns, you can actually specify them. So this here says where the title is contains the word creek and observed contains the word river. So you can do both of those. So those are some basic ways you can search this text document. Oh, I see it. There's questions here and they have not been scrolling by automatically. There we go. Sorry. Trying to pay attention to chat here and present at the same time is always a fun challenge. So these are ways that you can do. This is a basic full text search syntax. You can set up weighted text. So you can, for example, when you create your schema, you can say the title is more important than the observed. If I find this word in the title, score it higher. So here we've got schema title text. It's got a weight of 2. Observed has a weight of 1. And then the searches are all the same, but the title words will be twice as important as the observed words. So It's full text search, and so there are stop words. These are the default stop words that you get. The idea of a stop word is they're common words that aren't very useful in a search. So like a, and the are going to be all over every document because they're in English. But they tend not to be unique words that we're looking for. And so these are excluded in the indexing. You can override that when you create your schema. And since it's full text search, it also supports stemming. Stemming is the idea that there are grammatical variations of words that are effectively the same. So for example, if I were to put in the word give, give should match give, gave, given, and giving. Because these are all really the same word. So if I'm looking for give, I would expect to find a match to it in the past tense as well as the present tense. And that's obviously a language specific feature. And so there's an assortment of languages the stemming is supported by. And so you can pick one of these ones here. The thing that strikes me as really odd here is that you've got mostly a bunch of Western European languages, of course, right? Although you've got Arabic here, which is nice. And then the only language from the Indian subcontinent that's there is Tamil. And that struck me as a rather random choice. You think Hindu or Hindi would be the most popular choice there, but they picked Tamil. So probably means that someone, and we're using a library to do this. And so someone on the team that developed that library probably spoke Tamil. That's probably what it is. But I just thought it was oddly specific. So does stemming. And so to do this big query that I showed earlier, find the word creek in Ohio and Kentucky, class B, more than 75 degrees and near Cincinnati. To find creek, we just put in the word creek. Easy enough. And so I'm going to go ahead and do a search here against the database. You'll see that I don't have any indexes. I need to create an index first. So I'm going to npm run index. That's going to run my create indices code here. And all this does is open up Redis, get Redis IO here. I actually drop an index that exists already, but here is a call to ft create on hash prefix is some variables, and here's my schema. And so this is very similar to the code that we have seen in the slides, except just a little more extensive. So this is not much code here at all. I've got indices now. If I go back to Redis Insight here and hit refresh, it says, oh, look, there's an index I can use. And I can just do a search for the word creek. There we go. That has returned all the Bigfoot sightings that have the word creek. There are 827 of them. If I want to add creek and river, we can see that that drops to 174 documents. I can actually do, let's try this out here. Creek, river, limit, 0, 0. And then here we just get the count, right? So easy peasy. Let's look at tags. How do we use tags? So to use tags, we of course got to create a schema that has a field with a tag. And then we actually have to, we can't do it sort of across the board for the entire document like we can with search. We have to specify the specific field always with the tag. And here we're saying we're going to look for states, and we put it in curly braces. So state colon in curly braces Ohio will find any Bigfoot sighting in the state of Ohio. You can use an or to get Ohio or Kentucky, so that we get everything that's in Ohio and everything that's in Kentucky. And anything is tagged with either of those. We could use things with spaces in them. So here we've got West Virginia. We're going to find all the Bigfoot sightings in West Virginia. But I haven't escaped this white space, but you should. Because in this particular case here, if we're looking at classification, the stop words will get in the way. And so if I just do class space A, I'll get an error because A is a stop word and it wasn't indexed. But if I escape the space, then it treats the class space A as one entire word. And so you need to do that if you've got a stop word in there. So escaping your space, your white space in your tags is a good practice. And things can be tagged with multiple things. So I could have my classification string could be class A, comma, class B. And if I put those in quotes together like that, it will match them both. So I need all Bigfoot sightings where it's Class A and it's Class B. So this does an and, just like we did when we did like creek, space, river. Same syntax. And so to expand our query here to be state, Ohio or Kentucky, and classification Class B. So the query I'm building up here is one from a memory with my father, right? I remember being by a creek, and we were somewhere near the Ohio River, so it was probably Ohio or Kentucky. And I know we left a bunch of footprints around that people found. And so, and I remember it was a warm day, it was over 75, and it was somewhere near Cincinnati. So I'm trying to find, a specific memory with my father so I can figure out where he's hiding out at. So let's go ahead and try this state, Ohio, Kentucky, classification Class B. So we've got contains creek. The state is Ohio or Kentucky. And the classification is Class B. That should work. And we can see that we've narrowed it down. We now have 33 matches. So we're getting closer to that time I spent with my father. So let's move on. Let's do some number searches. We got fields that are numeric. We're going to play with temperatures. So here we're going to do our search again. We've got a search for a high temperature in a particular range. So we use square brackets for numeric searches, and it defines the range we're looking for. So here we're saying give match or find any high temperature that is from 60 to 75 degrees inclusive. So 60 or more, 75 or less. If we want to just do 60 or more, we just set our upper bound to plus infinity. If we want to do 75 or less, we can set it to minus infinity, the lower bound. If we want to get everything that's a number, because it's possible this temperature field is populated but has an empty string, this validates that it is indeed any number that exists at all by using negative infinity and positive infinity. If you don't want it to be inclusive and you want it to be exclusive, so more than 60 but not 60, less than 75 but not 75, you can use a left parent in front of it. So that's the syntax for matching numbers. And so we can now say I want a high temperature of 75 or higher. So let's add that to our query. Say at temperature underscore high, colon, square brackets, and we want 75 positive infinity. So this should narrow us down from 33 to an even smaller number. Now we're down to 11 searches. I'm starting to narrow in onto where my dad might be hiding out. Cool. So let's add the last element here. Let's add the geolocation. I didn't have a good pun for the title here, so this is just punless geolocation. So here we're creating our index. We're making our location to be a geofield. Now, to make a location a geofield, it has to be formatted in a specific way. We can't just throw some coordinates at it. I mean, we do, but they have to be in a specific format. And that format needs to be in number, comma, number. And the first number is the longitude, and the second number is the latitude. You might think this is backwards. It feels backwards because I always talk about latitude and longitude, but this is longitude and latitude. And the reason for this is because Redis was built by Salvatore Sanfilippo, and he's Italian. And in Italy, they say the longitude first because that's the convention there. So that's why Redis works that way. So it works for people that are in other parts of the world. And so, of course, negative numbers are west and positive numbers are east and north and south accordingly. But if you have a string that's formatted this way, then we can treat it as a geofield. To actually search on those geofields, we use the square bracket syntax like we did for number ranges, except we provide more arguments. The first argument is the longitude. The second argument is the latitude. The third argument is the radius that you want to search by. So I want to search 50 within 50 whatevers. And then the fourth argument is the units I want to use. And so this particular thing would find Bigfoot sightings within 50 miles of that coordinate, which happens to be Cincinnati, Ohio. It of course supports other units of measure. You can specify feet, so you can get Bigfoot sightings vary within 100 feet. And of course, it supports metric as well. And so you can specify meters and kilometers. And so we can also now find Bigfoot sightings within a particular range. So let's expand our query to include location 845120. Click on that guy there. At location, colon square brackets, negative 845120. And then what was the other one? 39 1031. And then we want 50 and we want miles. 39 1031, 84. Yeah, okay. I've typed all that correctly. Space there just because reasons. If I run that, we have now narrowed it down to merely 2 matches. This is enough that I could start doing some experimentation, right? I could probably find my dad with this data. So we put this all together. Here's our entire query: creek, states of Ohio or Kentucky, classification, class B, temperature 75 to infinity, location within here. Let's return a couple fields so I can figure it out. Let's look at return state and county. Oops. Want it on that one. So I know what county to go start looking at. And so Bigfoot sightings 45281 and 4972 are both in Preble County, Ohio. So odds are good that my dad's down there. I should go look. So that is how we can search all of our hashes using Redis. We covered full text search and we covered the indexing, but we haven't talked about aggregation yet. I've already done the demo, so we'll skip that. Oh yeah, I forgot about this slide here. We've got some sort of SQL equivalence here. So this is for when you go and look at things later. If you go and look at these slides and you want to say, well, I want to do the thing where, where a number is greater than 10. Well, then this is the syntax used. It's just a little cheat sheet for I've got SQL and how do I turn that into Redis search. So let's look at aggregation. We got about 15 minutes here for aggregation, so that should be fine. Aggregation allows you to do grouping. So in addition to querying, we can group the results of our query. At its heart, aggregation is querying. It's searching just like searching is. If you look here, the syntax is identical. We call aggregate instead of search. We provide the index we want to search, and then we provide a query. In this case, we're doing star to return everything, but we could put any query one in there. We could put the query that we just did in there. And then once we've queried our results, we can run them through a series of filters to filter them down more. We can run them through transformations to take a field and create a new field by converting them, by multiplying them, by uppercasing them, all sorts of operations. We can run them through some grouping operations where we group them by a particular field, like group them by state, and we can sort them in any way we want. And this is not a filter, transform, group, sort, we're done. This is a pipeline of whatever we want to build. So we could chain them together in very complex patterns. So we could, do a transformation, group by a newly transformed field, and then given that data, filter them out and transform them again, and then sort the final result and do all sorts of things. To filter in many ways kind of works like query, but it's got a different syntax. It's happening after the querying, but in some ways, the syntax is more familiar to anyone that's written code in the last 40 years, right? So here we're saying filter by the high temperature greater than 75. I can do greater than equal 75 there as well. And you can use little or statements and double ampersands for ampersands. This is basically C style if statement syntax stuff, right? I can do simple math against these fields when I'm filtering. So I can take the modulus of the humidity equal to 0 and the humidity is greater than 50. And so this particular filter will return all records or filter out records where the humidity is greater than 50 and it's even because, that's a reason. That's a thing you'd want to do, right? There's functions you can call to filter on. So filter where, for example, the temperature exists. If there's no temperature, I don't want to do any operations on it. I want to filter out where the temperature is missing. And these functions can even be used with operations. So here I'm looking for, I'm calling floor on the low temperature, and then saying where it's greater than 32. And these functions can even handle timestamps. So you could have a Unix timestamp in your hash that you're searching against, and get the day of the week out of it, for example. So day of week would return 0 to 6, whereas 0 is Sunday and 6 is Saturday, and all the numbers in between, or all the days in between. And so this particular one would filter out and say, don't include Sundays. So that's filtering with aggregation. Allows us to in some ways do some more sophisticated filtering that we can't necessarily do with querying, because we've got these functions. Here's a big list of all the filtering functions. I'm not going to go into them, other than to point out that there are geolocation ones. We'll get the distance between two fields that you have. So you might maybe have two geolocation things in your data set, and you want to find things that are within 20 miles of each other. You could do that using these filtering functions. Transforming your outputs, use the apply word. So here we're applying, the simplest case is simply to rename a field. So temperature underscore high becomes as high underscore F, high AF. And so now we've got high temperature Fahrenheit. We can also perform math transforming these things. So we can take that high temperature, multiply it by 5, divide it by 9, and you get the Celsius. And so now we got a new field, which is the Celsius temperature, the high temperature in centigrade. We can call functions just like we did in filtering. Here we can say if the field exists, write out a new field called high exists. That'll be 1 if it exists, 0 if it doesn't. And we can do the timestamp things as well. So here we can get the month that a particular event happened by adding 1. It's 0-based, so we get 1 through 12 for us humans. And these functions that I'm using here, to get the month of the year, the exists, are exactly the same functions that we used for filtering, except that we're just taking the results of them and creating new fields. Pretty cool. So now that we've sort of filtered through our data and created the new fields that we care about, let's group them. To group, we use group by. And then group by takes a number of the fields you want to group by. So we want to group 2 fields, group by state and classification. So this will create a group for all the states, all the classifications. So we got 50 states, we got 3 classifications. That turns into 150 groupings in our data set, assuming we have values for all those things. And then these group bys pipe into a reducer. And there are several of them. This reducer is count, and count doesn't take any arguments, so it just takes a 0. And then we create a new field name for that counting. So this groups them by state and classification and gives us a count for each state and classification. You can do counts, of course, and you can do lots of other expected mathematical operations for the grouping. We got the average temperature. We can do average. We can do maxes. We can do mins. And so like I can get the average high, the average low, the max temp, the min temp in any given state and classification. Your group by does not have to have any arguments on it at all. You can just pass a 0 and say, I want to group my entire data set as one big massive group. So this grouping here would find the maximum temperature in the entire data set, the minimum temperature in the entire data set, and using a quantile, we could get the median. So that's kind of cool. So that's how you do grouping. And here's a list of the reducers that are available. You've got count distinct, but both useful. Count distinctish is interesting because it uses a probabilistic data structure to get an approximate count. This is useful if you have a particularly large number of things. If you've got millions of things that are going to, in a particular group, and distinct things, then count distinctish will give you a faster and smaller memory footprint for that counting. Some min, max, average. You turn them into lists. You can get randoms. Lots of reducers here. Last but not least, we've got sorting. So to sort, we just specify sort by, and we give it the columns we want to sort by. And that's pretty much it. We can mark them as ascending and descending. Either they're ascending by default. We can, as a result of that sorting, we can also filter out, like, give me the top 5. So we can sort by county and state and give me just the first 5 county state sorted combinations. And that's it for sorting. Sorting is pretty basic. So I've got a few fun queries to sort of put this all together so that we can get some context around it and understand the data a little bit. I think I got time to run one of these. This particular query here is going to count all the Bigfoot sightings by year and month. So I can get a view of how Bigfoot sightings have grown in frequency over time. We've got here, we're looking at our index. We've got our query. This is our actual search query. We're saying, give me ones that have a timestamp that's positive, 0 or more. If there's no timestamp, or if the timestamp's negative, we can't use it. And then I'm creating a function. I'm calling apply, and I'm calling year to get the year of that timestamp. And I'm calling apply again to get the month of in that timestamp. So this gives me the year and the month. And then I'm grouping by year, these fields I just created by year and month, and I'm counting them. And then I'm sorting by that year and the month, and I'm doing a limit of 0 to 10,000. Say, I know there's going to be a lot. I really just want them all. And so if we go out into Redis here, I've got a query ready to go here, right here. I only need these. I need that bit right there. And if I change this to aggregate, this is going to call FT aggregate on this index. I can pass in my query here. So I've got timestamp. There's my apply. There's another apply. There's my group by. There's my reduce, my sort by, and my limit. Let's run that. And we get 524 documents. So 1970, month 4, it's got 2. So May has got 4, June has got 3, and and we got lots of results here. Right. So cool. We're able to group that. When we actually take this data, I took this data there in Redis Insight here. We've got an option to export entire data as CSV file. I've done that. And then I use that to build a graph using Google Docs. And I plotted out this graph here. And we can see here, we've got a spike in Bigfoot sightings in the mid 70s. And we've got one in the mid 2000s up to about the mid 90s up to about the mid 2000s. This, looks like, in 1995, that's when the X-Files came out. Maybe that's why the Bigfoot sightings went up. This is when Steve Austin, famously, the $6 Million Man, famously fought Bigfoot in the 70s. By the way, fun fact, Bigfoot was played by Andre the Giant back in those TV shows. But what we're really noticing in this data here is that this is 1995 is when the Bigfoot Field Researchers Organization website went live. And it's also pretty much when the internet happened. And so we're seeing a jump of sightings that really correspond to more people being able to report their sightings. And we see a decrease here, I think, because everyone got smartphones. And so it's easy to say I saw Bigfoot when people can't say pics or it didn't happen. And then later on they were able to. And so I think they dropped off. The other thing that's interesting here is you see it's spiky, goes up and down. And what I suspect here is that this is winter versus summer. And to prove that out, I do another query. What months do Bigfoot sightings happen in? And so this is a similar query. It's just doing a count again. But this query will show us that the most common month is October, which is when the trees are all bare, but people are still outside. The second most common month is July. And so this is showing that Bigfoot doesn't hibernate. It's showing that people are outside and they're seeing Bigfoot sightings when they're there to see them, not necessarily when Bigfoot is hibernating. This doesn't tell us that Bigfoot hibernates. This tells us that people are in the woods in July, August, September, and October. And this idea is further reinforced by the next query, which tells us what day of the week does Bigfoot sightings happen on. So if we go here and we look at our data, we see that Saturday is the most common day for a Bigfoot sighting. Why Saturday? Well, how many times have you been camping on a Friday? You set everything up, spend all day Saturday in the woods, and then Sunday morning's your first thing out. you know, you head out of the camping, but you spend all that day Saturday in the woods. And it's actually interesting that Friday and Sunday are both the second most common days because it's the weekend. It's when people are out doing things. They're not at work. They're out in the woods looking for Bigfoot. So kind of fun data. I've already demoed one of these already, so I'm going to skip that. Here's some resources, links to all the stuff that I've talked about, Redis.io, RediSearch, Redis Cloud here. If you want to get up and running with RediSearch quickly, you can just get a cloud account and add RediSearch to it, and boom, you can start playing with it. And a bunch of other links, including stuff to the data set and Tim Renner's blog, which you should totally check out. All these links can be gotten from this QR code, so go ahead and scan that. I promise I won't rickroll you with it. It does legitimately go to github.com/GuyRoyse/finding Bigfoot. So go check that out. And I don't think I have time for questions, maybe one, but so I'm gonna skip that. Some other links to check out. I run the Redis Discord server, so if you have questions, we have a dedicated chat channel for that. We got a YouTube channel, and we got free courses on Redis University. And that's all I've got. My name is Guy Royse, and thanks a lot.
Should I go ahead and get started? Excellent. All right. Good morning or good afternoon, everyone, depending on where you're joining us from. My name is Sam Nasr, and this is the session on Introduction to LUIS, also known as the Language Understanding Intelligence Service. A little bit about me. You can find me on Twitter at Sam Nasr. I've been a software developer since 1995, and I'm currently working as a senior software engineer for NIS Technologies. I've also been certified with several certifications from Microsoft, and I am running the Cleveland C# VB.NET user group. Excuse me, and I also host the .NET study group that meets online, and you can find all that meeting information on meetup.com. In addition, I've authored several articles for Visual Studio Magazine, and I've been a 5-time Microsoft MVP. So getting into our presentation, with LUIS, basically, if you look at the computer input and its evolution through the past, basically it started off with the infamous punch card that we now see in museums. Then we progressed to keyboards, which we still have. And then it migrated over into touch, where we can swipe left and swipe right. But now we're taking it to the next level where we can actually speak to our applications. And obviously with many of our mobile devices, we're able to do that. But how can we incorporate that into our actual day-to-day applications? So we're going to take a closer look at that, and LUIS will help to implement that. So once again, LUIS is Language Understanding Intelligence Service. It is built on interactive machine learning provided by Microsoft Research. And it uses a language model where we have to train it multiple times to be able to parse natural spoken language. It is not so much trained on the ordering of the words in a sentence, but more of what is the general purpose that the user is trying to get across. So for my demo, I'll be using a car dealership. And when you go into a car dealership, a lot of times you want to buy a car. And so you can phrase it in a variety of different ways. You can ask them specifically, do you have a Mustang in stock? Or I would like to buy a car. Or can you sell me a vehicle? All these are 3 different sentences structured slightly differently with different words, but the meaning is still the same. The user still wants to buy a car. And so we can use the natural spoken English and be able to parse it out in LUIS and be able to get the intent of the user. We do this by essentially, after we build a model, we have a REST API endpoint that is then made available where we can use that in our application. And so the end result is basically making an API call, submitting the query string, and then getting a result back. So we submit a text string as the user input, and then it returns only the parts the developer needs to interact with, meaning what is the intention of the user, and LUIS will tell us what the confidence rate is for every intention that it reports back. So the Language Understanding Intelligence Service, basically what it is we train the model, and we after it's trained, then we submit the request, and then it comes back, and as you see here, we have the JSON format for the data that is returned from Lewis. Pardon me. So the language models are specific to your Lewis application, meaning that I will set up an app in Lewis.ai, which is a portal for Lewis. I will train that model and it will be specific only to my application, meaning I will have a subscription key that I will use, or an app ID rather, that I will use for that app. And only that app will be the one that I can access, meaning someone else can train another model, but it's going to be isolated from the model that I train. And it forms the basis of what the user means. So basically, if we look at the core structure of a sentence, natural spoken English, you would say, I want to buy a Mustang. So within that sentence, there's a noun and then there's a verb. And in some cases, maybe an adjective. If I say I want to buy a red Mustang. So we take that natural spoken English and we divide it up into pieces, parts. And as you see here, the core parts of the language model are the entities, which are essentially the nouns in the sentence, which is a Mustang or an Explorer or whatever vehicle might be. The intent is the verb. Pardon me for 1 second. Pardon me. Sorry. So the intent is the verb, what the user wants to do. And in this case, we're calling it buy car as the intent. Now notice, the intent is something that I can name anything I want. So it is not a natural word here, but rather you'll see that it's two words concatenated next to each other. This is simply, the intent is a token that is passed back from Lewis. And so I called it buy car. And then an utterance is essentially a sentence that combines everything. It has the entities and the intents all within the utterance. And so with that, I'm able to decipher it and find out what it is that the user wants. The result set, as I mentioned, we get back a JSON result set from making that API call to Lewis. And for starters, it gives us the query string that was submitted. And then you'll see that it may or may not have multiple intents after it. So let's take a look at the car dealership example again. When I go into a car dealership, I may want to buy a car. I may want to trade in my car. I may want to get my car serviced. There's a variety of different things that I would want, right? So if I'm training an application to act as a kiosk in a dealership where a user can walk up, enter in whatever command they want to do, and then we can facilitate that through Lewis. When I submit that query string that the user has spoken or has typed in, it'll come back with a variety of different intents that I train my model on, but it will give me a confidence rating. And more importantly, the highest intent is the one that has the highest score, meaning that's the one that it's most confident in, that is the intent of the user. So we see over in the slide that the top scoring intent is by car, and the score that comes back is a 99.9999995 confidence rating. And so the other intents that are listed, in this case, is just one intent. But you'll see in that demo, I can have multiple intents, and you'll see the confidence score is much less than the top scoring intent. Within machine learning, this is a quote by Tom Mitchell from 1997, and I think this is something that only a mathematician can write. A computer program is set to learn to perform a task T from experience E if its performance at task T, as measured by a performance metric P, improves with experience E over time. Essentially what this is saying in a very algebraic type of way is that with our machine learning, it gets better over time with repetitive training within that task that we're trying to get it to do. So for example, I want to buy a car, very straightforward. Well, what about if I go into and talk to a dealership and say, will you sell me a car? Different sentence structure, but I can train it. If it doesn't catch it from the first time, I can train it so it knows that the second sentence, will you sell me a car, essentially has the same intent. So I keep submitting different phrases and I keep training it until I am confident in it that I covered a lot of bases and the model is robust, will respond back with a proper score and the proper intent. So essentially what this is saying is just repetitive learning and that performance of the machine learning model will improve over time. So when building a Lewis application, what is involved? First of all, you need to create an Azure account because you need to have a set of keys that you're going to utilize for the Lewis application. Once you have an Azure account and you create a resource group with a specific resource for Lewis, then you can take that key and then you go over to lewis.ai, which is a portal for setting up your language understanding model. And then from there, we add in our entities, our intents, and then we train it with utterances and see how well it performs and continue to train it. And then after we train and test it, then the next step is to actually publish it out. And once we publish it, then we have a REST endpoint that we're able to utilize in our code. And then we can submit a query string and be able to get the intent of that user back. So the best way to explain things is by demo. And so that's what we're going to do. And let me go ahead and open up the Azure portal. That's not it, but this is it. So here's my Azure portal. And first and foremost, I'm going to create a resource for Lewis. But in order to create a resource, I need to have a resource group. So within my resource group, I already have a Lewis application created here, but to create it, all I simply do is just select create, and then I can drill down into AI machine learning, and I can continue further to search for it in the marketplace, or I can just take the easy way out and just type in language understanding, and I need to spell that correctly, of course. And this is the resource that I'm after. So all I had to do at this point would be click create. And it's going to go through, prompt me through a few items, basically regarding the authoring location, where I want it to be executed, whether in which location. And since I already have one created, I'm going to back out of this screen. But essentially, it's very simple and very straightforward. So within my Azure subscription, I'm going to have a set of keys that will be created and given to me. I will then take those and then go over into Lewis and then create a new application here. So let me go to the top of the Lewis portal. And here I created several applications that are all targeting a language understanding model. So in our case, I'm going to go ahead and create a new one, and I'm going to call it Test App 6. As you can tell, I've done this presentation a couple times, so that's why there's multiples there. But so I answer the prompts. The culture that I want is English. I can select from a variety of other languages, but we're going to stick with English US. Type the description, call it Test App. And then we want to utilize the prediction resource, which is basically an application that is used for querying the prediction endpoints. So we're going to call this Test Lewis at the end. Click Done. And then here's some verbiage on what you need to do as far as building your model and then testing it, but we're going to skip through that. Now I have my application created, and basically it's pretty bare right now because I don't have any intents or utterances. So the first thing I need to do is to create an intent. And in my case, we're going to call it buy car. So what's a sample input that the user would say that would qualify for this intent of buying a car? And I would say, I want to buy a car. Enter. Now I need to dissect it and specify that this is an entity. Car is an entity, so I will specify the entity name here as car. And it's saying for the entity, there are basically two types. There's the machine learned, and then there's a list. So with machine learned, it's basically something that the machine will learn over time. So A generic sentence like, I want to buy a car, relatively straightforward. What if a user said, I want to buy a Mustang, or I want to buy a Corvette? Well, we need to train it so that it looks at that noun of Corvette or Mustang as a car. And so that is going to be machine learned over time. With list, on the other hand, that is essentially a finite list of items. So take days of the week, the months of the year, airport codes around the world. That is a finite list. It is never changing. And so in my case, I'm going to select machine learned, and I'm going to select create. Okay. I'm going to add in another sentence. I want to purchase a Mustang. And then within that sentence, I'm going to define this entity. And here's a list of other entities, but I'm training it. I'm setting it up, I should say. The training will come in just a second. I'm setting it up to say that Mustang actually is a car entity here. And within this utterance, with that entity, it falls under the intent of buy car as listed up on top. Okay. So now that I've gotten this far, what I need to do is to be able to train my model as the next step. And so if you notice over in the upper right-hand corner, we see that the train button has now been enabled. And so I click train, and that'll take just a minute to go through. So the predictions have been loaded, train completed. Now I can test it within the portal by submitting in a sample utterance or a sentence. So we already have, I want to purchase a Mustang, I want to buy a car. Let me combine the two and say, I want to buy a Mustang. So it's loading that, and then as you see here, it comes back with the intent of buy car, and that has a 95% confidence rating. Okay, so it's able, even though the sentence structure is different than what I submitted earlier, it still comes back with, it figured out that the intent of the user is buying a car. So let me try another sentence. Can you sell me a Mustang? And again, that comes back with a 79% confidence that the user wants to buy a car. So it's able to decipher with a varying sentence structure that is the intent of the user is to buy a vehicle, or buy a car, I should say. Okay, let me pause here and see if there's any questions in chat. Bhaskar, are you seeing any questions in chat? All right, no Bhaskar and no chat questions. So we'll go ahead and continue on. So let's say I want to add in another intent so we can see how it varies. We'll go ahead and create an intent of, I want to get an oil change. Sorry, that's the utterance. Let's call it service car. And a sample of that would be, I want an oil change. So I'm setting that up as machine learned. So oil change is the type, pardon me. That's what the user is after, essentially service car. And then the service type is oil change. Could be a transmission change, new tires, etc. Pardon me. Once again, you see my train button is now enabled. So I can click train. And it'll take just a minute. And now it came back that it's processed successfully. Now I can test it. And now I can say, I want to buy an oil change. Okay, again, different sentence structure. But you see it comes back with a 73% confidence rating that now it's service car and not buy car. So it's able to decipher what the user's intent is without essentially having it in a specific order in the sentence. So once that's done, you notice that now my train button is disabled, and you see as the text that came up in the bubble up says app up to date. So now I no longer need to train it. Everything's up to date. So now that it's done and I'm satisfied with the results, now I can go ahead and manage my application. And so here with the management, here you get an app ID for that specific app. And I can specify whether I want to make that endpoint public or not. And I will select on. And then I'll go ahead and click publish. And we'll talk about these settings in a little bit in upcoming slides. But we'll go ahead and make it a staging slot. Select done. And now it's telling me that it's been published. Access your endpoint URLs. When I click that, it's giving me a URL here. And now I can take that and plop it into my browser. And you'll see that at the very end, it says your query here. So I can type in I want to purchase an oil change. Click enter. And then you see the JSON that is returned to me. And let me expand that a little bit. So first and foremost, actually, let's do this. Let's take this, put it in a notepad file so we can better decipher it. And we'll do word wrap. So I want to purchase an oil change, and it's coming back with the predictions that the top intent was to service car. And then in addition, let's break it up like this. So service car comes back with a score of 59%. That's the top rating, the highest intent. But then there's other intents that I set up in my system, and it's bringing those back with a 30%. So it's 30% confident that the user wants to buy a car, but it's 59.44% or 0.45% confident that the user wants to actually service their car. And so it'll get trained over time, but in the meantime, it's telling you what the confidence rating is. And so you go off by the highest scoring intent, and you put that in your code, and you're able to manipulate the application accordingly. So obviously, you're not going to have a user type in a query string in a browser like this and be able to read JSON. Instead, looking at the code, I built a sample application here. And all it is basically, it's going to be a window that's going to show, as soon as it comes up here in just a second, it's just going to be a window that's prompting the user for what they want. And this would be something that would be placed in a kiosk at a dealership that would ask the user what their intent is. So it's a window that reports, what can I do for you? And we have a text box here for entering the text. You click the search button, and then it'll display the results in the bottom pane. So once we click search, what actually happens is it calls the Lewis parse method. This is a method that I had built. And it's an asynchronous method because it's an API call. We don't know when we're going to get the results back. So it's always good to make it an async task. With that, what we do is we actually access the application by using that URI that we received earlier. And so we take that URI and then make the call asynchronously. And then we wait once we get the message back, and we check to see if it's successful. Once it's successful, then we read the JSON and we check to see, does the JSON have more than one intent, one or more intents in it? And if so, we want to read the highest intent. So I'm calling mine top intent. Once we get the top intent, then we can do a switch statement and figure out what intent is the user based on what I set up in my application. So it could be buy car, could be service car, or in some cases, if the user enters in garbled text or something that doesn't make sense, we just simply reply back with, please rephrase that, I didn't understand you. Okay, so let's run through the application. And while we're doing that, I'm going to check to see if there's any questions in chat. And still none. Okay. All right, so now within my window, I can say I want to buy a car. And when I click search, then it goes through the application. We got the URI hard-coded in here. And then all we're doing is simply appending the query string, which is what the user entered. I want to buy a car. And then we go and continue on. We check to see that the status code is successful. And then within our intents, we have, come on. Okay. Not showing. But I know that we have more than one intent back, and then we get the highest scoring intent. And then we continue to inspect that even further. What is that top intent? And in our case, it was buy car. And so now we can respond accordingly. So when now the user, his intention is to buy a car. So our answer is, well, we have X number of cars in stock. And what we have here is basically the car.car inventory. And what this is an object that I built in, and we can go to the definition and take a look at that. So this is an object that's built in, so I don't have to rely on a database for this demo app. And essentially, I have 3 cars that I built in stock. They are a Chevy Corvette, a Ford Mustang GT, and a Mercedes C300. And just to get the conversation started with the user who wants to buy a car, I let them know that we have 3 cars in stock. So I'm getting a count on the cars that I have in my dealership. Okay. Any questions? Okay. So continuing on, we can stop our application and let's go back into the slide deck. So entity types, there's a variety of them. We saw that the 2 that we worked with mostly were machine learned and list, but there are other entity types that are available. So just to reiterate, machine learned are basically entities learned from the context as we train the model repeatedly. And so the data that's provided is not always well formatted, but it has the same meaning. And as we saw, purchase a car, I want to buy a car, sell me a vehicle, all those are different. They're not well formatted, but we're able to derive the entity type out of it. A list type is essentially a fixed closed set or finite number of items within the list to choose from. And a regex, well, all developers know what a regex is, right? It's a regular expression. And so we can set up a pattern. So for example, with phone numbers, you have an area code, at least in the US, you have an area code, 3 digits, -4. So we can set it up to look for that regular expression within a sentence or an utterance. And then pattern.any is essentially any variable length placeholder that's used in a template utterance. So once we set up a template, we can specify that there's a pattern that lies within it. And that pattern essentially is going to be what the entity is. As far as languages, as you had seen when I was creating my model, I had a variety of languages to choose from. And there are multiple languages that are offered with pre-built entity support, meaning they already have pre-built models available. And I'll show you that on the next slide. But a variety of languages available, and more importantly, pre-built models. So you have some things like date, time, number, percentages, temperature, geography. All these are different models that are already built in. And many of them, depending on the documentation at the time, will be available in a variety of different languages and cultures. As far as managing your Lewis application, you can monitor your application dashboard and the usage and the intents targeted. So for example, if we go over back into our portal, we see that we can go to our dashboard and we'll refresh. And although we did have a hit today, it doesn't show it here, but it is a little bit slow to respond. But essentially within the dashboard, it'll show you the endpoint hits per day, and then the number of correct predictions, number of incorrect predictions, and so on. Predictions per intent. So here, for example, we had the buy car intent and the service car. And as you see, the number of utterances that were set up, we have one utterance and we have two utterances for the buy car. And then it shows you the number correctly predicted and the number incorrectly predicted. In our case, it was 0 incorrect. So we did a good job. And in addition, it shows you any predictions that may have had errors in more detail down here. And let's jump back into our slide deck. So we're able to monitor usage and the intents that were targeted. We're also able to manage the keys that we can utilize within the application. And so with that, again, let me show you back in the dashboard. If I go over into My Lewis, you'll see that within the endpoint, no, sorry. There it is. We have the app ID that's used for part of the API that is published. So once I click publish, this app ID will be incorporated within it. And then in addition, I can set up my Azure resources and modify the keys that I'm using for my app. And let's go back into the PowerPoint once again. In addition, I can utilize batch testing. And with batch testing, what this allows me to do is to be able to send in an array of utterances in JSON format. So I can set up a spreadsheet and basically fill in all the utterances and be able to submit that and train it as a batch style, as opposed to individual tests that I ran in my portal. The entity indices should be supplied using character counts. So as I submit my JSON format, I need to specify where the entity is using the indices and character counts. So I specify if it's the 5th element in the sentence or the 4th element, where exactly is my entity within the utterance. Also, keep in mind, entities are not allowed to start or end in the middle of a word. And a maximum of 1,000 utterances are allowed in each file. So certainly I can have multiple files, but per each file, it's a maximum of 1,000. And to do that, let's go back into here and we'll go into the tests. So here's my test panel. If I want to do batch testing, simply click on the batch testing. Pardon me. And then I can select import, and it will allow me to select a file in JSON format and be able to upload it. If I need help with the syntax of how that file should look, basically it would be something similar to this. In addition, when I go to publish it, I have the options for sentiment analysis and speech priming. And by selecting change settings, then I can select to turn those on or off. What do those mean? If we go back to our slide deck, let's go over into, skip to the next slide. I apologize for my hoarse voice. But publishing options. So sentiment analysis allows Lewis to integrate with text analytics to provide sentiment and key phrase analysis. What that means is I need to find out what is the sentiment of the user. So if I'm, let's say I'm asking for user feedback in my kiosk, and the user said, the experience was so pleasant, it felt like a hole in the head. Obviously, there's sarcasm there, and he's expressing displeasure. So I can use the sentiment analysis to find out, was that a good feedback or a not so good feedback? And it will return a score between 1 and 0, similar to the confidence score that Lewis returns back with predicting the intent of the user. So it'll be 0.67 or 0.99, but essentially it'll be between 1 and 0. The other option is speech priming. And with speech priming, it's basically the process of sending the Lewis model to speech services. So if you recall in our first slide, we talked about various methods of input to an application, from punch card to keyboard to touch and swipe to now speech. So now I'm able to process actual written text, but if I want to go a step further, I can actually utilize speech priming, where now I can collect text, spoken speech from the user, turn that into text using the speech priming service, find out what the user wants in Lewis, and then when I get it back, I can also convert that to speech as well and have it be spoken back to the user. But the key thing here is that everything works off of that, the model and the web API, where I submit a text string to the Lewis application. But I can add speech priming on top of that to actually have spoken language added in. A couple of gotchas to keep in mind. You must have an Azure subscription prior to logging to Lewis AI, otherwise the top navigation bar will not be visible. Don't forget to publish the application after training it. A lot of times developers will think, okay, it's already trained, but why is it not working accordingly? So after I train it, I need to actually publish it, and then I'll get that endpoint again. Also, in versions 1 and 2, once you selected a culture and you started building your model, you couldn't change the culture after it. However, versions 3 and later of Lewis, you are now able to actually change the culture once it's been created in the model. And last but not least, there is a delay in the dashboard metric refreshes, so exercise a little patience there, but essentially it will appear. And then lastly, the Bing Speech API, you can use that in a browser. However, a WebRTC compatible browser would be required. In this case would be Chrome. So other browsers like Internet Explorer, if you're still using that, that's not going to offer that feature. All right, so typically I like to ask what it is that we learned today, but I know that a lot of times over a virtual conference, the audience is a little bit reserved. So just wanted to do a recap of what we covered. So with Lewis, as again, stands for Language Understanding Intelligence Service. We create the application by setting up a resource in our Azure portal, and then we take the keys that are provided within that portal, and then we utilize that in our Lewis application in the Lewis portal, lewis.ai. And some of the gotchas were that I need to set up my application or my resource first before I set up my Lewis application. Also, don't forget that after you train the model, you actually need to publish it again, even though it's already been published. Some references. Microsoft Docs has some great write-ups on this. There's some links that are provided there. In addition, if you'd like an evaluation of can Lewis be a fit for an application that I'm working on, with NIS Technologies, we offer a no obligation consultation regarding AI and cognitive services, Lewis obviously being part of it. So feel free to reach out to nistechnologies.com. In addition, there's a lot of other courses, including cognitive services, that are available, and you can check out the website under the education section. And lastly, my contact information. If you have any questions that I can answer for you, you can reach out to me at snasr@nistechnologies.com. You can also find me on Twitter at Sam Nasr. And I invite you to connect with me on LinkedIn and to also subscribe to my blog, samnasr.blogspot.com. And so with that, if there are no other questions, I thank you all for attending, and I thank you for your time. Bhaskar, do we have any questions or comments from anyone? I don't see anything in chat. All right, thank you all once again, and we'll see you in my later session today on JavaScript communication features. Bye, everyone.
Yeah, you should be live.
All right. Thank you for joining. My name is Eric Bishard, and I am a developer advocate at Couchbase. I work with Node.js, so an advocate for JavaScript and Node.js and the Node.js SDK. And today we are going to talk about Ottoman. And Ottoman is a ODM for Couchbase. And let's go ahead and get into it. So in our agenda today, we're going to talk about a few things. First, we'll start off with a little bit of a background about Couchbase and what other types of document databases you might know of already and how it might be similar to or different from those. We'll talk about why you would want to use a JSON data store. Also, some basic data modeling and how to do relationships with data modeling. This is applicable to not only working with an ODM for Couchbase, but potentially working with any other ODM with another document database, or even without an ODM, just working with data modeling. We'll talk about Nickel, which is our query language for Couchbase, very similar to SQL. In fact, we call it SQL for JSON. And it is, you can use ANSI standard SQL in our Nickel query language. So that's great. If you're coming from a previous relational database and you know SQL, then a lot of that information that you already know can be carried over to working with Couchbase. Once we get through that, we will start talking about Ottoman.js. I'll talk a little bit also about the project, how you could potentially contribute if you want to. And then we will go into a demo and show you a little bit how you would set up a project or an API using Ottoman. And we'll also review some resources at the end. So choosing a document database, choosing a database in particular is a very big decision. And typically, this is something that you need to get right as a developer, because as your application scales, as you grow with your user base, this is a decision that you want to get right up front and not have to switch in the middle of building an application, especially once you start thinking about scaling. You know, what platforms to use for storing and delivering your application data. The question used to be, what relational database do I use? You know, and we were very used to working with tables, rows, and columns for everything. In fact, when my first 10 years as a developer, most of the time that I approached a project, it would start with pen and paper and mapping out exactly how my data was going to look in a relational database, whether it be MySQL, PostgreSQL, even enterprise level relational databases like Microsoft SQL Server. So, you know, now we kind of have an option to SQL or no SQL. That's the query. But I think with Couchbase, an interesting thing is that you don't have to necessarily forgo working with SQL. You can bring that knowledge over with you. And we can talk about that a little bit later. Some of the JSON databases that you might have already heard of, or probably maybe even know very well, MongoDB and Couchbase, they are the two most notable document databases. And knowing one document database from a fundamental perspective, you will pretty much know the other one, again, from a fundamental perspective, although there's a lot of differences between the two. Everything from the query language that it's going to use, how these individual databases scale, as well as ACID compliance, how indexing work, and a lot of other things like what services do they provide? Do they provide full text search, eventing, analytics, that kind of thing? So I feel pretty safe in saying that Couchbase ultimately scales better, but you know, that's not always what you're looking for. And one thing that we pride ourselves at Couchbase with is when someone does ask us these questions, we really like to think through the decision making with them and try to recommend the right course of action. And in some cases, people use Couchbase along with other databases. They just use it in a different way. So that's cool too. But one thing in particular is Couchbase gives you a lot of tools for scaling. Some of the other JSON databases that you might have heard of or know and use are RethinkDB, Azure, Cosmos DB, DynamoDB. And these are great. A few of these offered by cloud platforms, which are great if you're working on those platforms, but sometimes may not contain all of the maybe enterprise level features that you need, or maybe you're just more familiar with something like Mongo. So those can be a challenge to learn. Now, out of all of those, there's only one that can where you can bring your knowledge of ANSI standard SQL over and get up and running with their query language, and that is Couchbase. So why would you choose a document database even outside of choosing something like Mongo or Couchbase? And the decision might be around flexibility of your data, less schema, and also scalability and availability. How does that database scale? How can you achieve availability? What are the tools that help you do those things? So at Couchbase, we have flexibility in terms of schema, and that's pretty much the same with all document databases. So there's no rigid predefined schema. In a relational database, as I said, your data needs to fit into predetermined tables, columns, rows, and you need to have exact data types. In Couchbase, most document databases, every write can be a document of different size and shape. As long as it conforms to JSON, well, then you're going to assign it a key, and that value will be the JSON that you store in the database. So that's pretty cool, especially when you're working with a full JavaScript stack and just working with JSON from one side of the stack all the way to the other is pretty nice. So that's a good reason to choose document databases in the first place. Another can be, you might have requirements on how fast you need to write, how much data you'll be writing, and then of course, plans on how you're going to scale out your application over time. You could design your database based on your application with a document database. So you kind of let your application determine what kind of model of data that you're going to be using. For instance, your API, what does your API look like? And then what does your UI on the front end look like? Those things can be driving factors when using a document database, whereas with a relational database, you have to think of the data in a whole different mindset. And in a relational database, I always want to say RDBMS, but it's very hard to say that. In a relational database, you need to follow specific rules, normalization. This can break up your data, like I said, and create a lot of work, and just literally have to think in a different mindset around how to structure that data. And so that's one of the biggest kind of reasons why you would want to use a document database. At Couchbase, scalability is keys. Clusters and nodes that can easily be increased or decreased on demand. That's kind of what we do. Imagine that your system needs more demand in an event like a Super Bowl or a World Cup, and more nodes need to be added. So with something like Couchbase, the cluster can be configured, and you can make changes. You can either make changes in configuration to determine how that load is going to be distributed, or you can auto distribute it. So that's a cool thing to know about Couchbase as well. You have the one-dimensional scaling or auto scaling, as well as the ability to say, hey, I want this specific node to focus on queries. I want another node to focus on indexes. And then I potentially want to scale up this third node and create extra nodes for data. So all of these possibilities, in any way that you can think of it, is achievable through something like Couchbase. Now, a lot of this stuff I'm talking about right now is kind of more database administration stuff. Not every developer needs to know about this stuff, but it's good to know what these databases can do, so that you maybe at your company or on your project, you can bring these ideas to the forefront whenever you're thinking about making the choice on database. So on Couchbase, like we typically have 3 nodes for a production deployment. And of course, you can easily scale up those nodes, and this will cause a rebalancing. And with a platform like Azure, you can pretty much control this with like a slider, but with configuration, you can also set how you want your database to scale up. You can have as many nodes as you want for the most part, and you can scale those up for events that cause high demand, and you can scale them right back down when you don't need them. You can allocate a set number of nodes to handle indexing and querying, and only scale up, like I said, the data, the query or index, or any other configuration. And having a plan and infrastructure in place, like using our autonomous operator, which allows for the use of Kubernetes and its horizontal pod autoscaler. Those provide auto-scaling capabilities. So the database you choose is a major part for our customers' decisions to handle these big events, and things like Black Friday, Super Bowl, the summer travel season, and any sudden or even sustained user growth. Availability, probably the last thing I'll kind of go over on kind of like the database administrator side, but the way that we achieve high availability with the Couchbase cluster is through cross-center data replication. So the contents of a bucket can be selectively replicated to a bucket maintained on a remote cluster, and everything just kind of automatically replicates on its own. So Couchbase is a key value document database. Basically, you have for every document that you insert in the database, you have a key that goes along with it. And you can get, set, replace, and delete by that key. And so this is your kind of like key value operations. The normal CRUD methods allow you to look up a document by its ID. We also have support for MapReduce, like a view query, which allows you to look up one or more documents based on various criteria. MapReduce views, they're basically just a map function executed once per document, and an optional reduce function that can aggregate results from that map function. And these, the map and reduce functions that you can have with a Couchbase database, they're stored on the Couchbase server, and they're written in JavaScript. So again, JavaScript from the front end to the back end to the database and everything in between. It's just very nice to have to be able to work with JavaScript. And that we're here at JavaScript Friends. All of us like JavaScript, and these are great times that we're in where JavaScript has progressed to this great level that it's at, and we're able to actually use JavaScript all the way across the stack. And the data that we put into our database looks a lot like the database, the data that we're actually using in our application. So that's great. Use cases for a document database. There's a lot of them: caching, scaling user profiles, content management, gaming logs, travel booking, fraud monitoring. And just to go over a few of the use cases that we have with our customers that use Couchbase. So I'm going to just spout off a couple company names and kind of tell you what these various companies use Couchbase for. And you could also think of this as kind of why do they use document databases as well, document databases and caching layers and all this kind of stuff. This is different than using relational databases. So LinkedIn uses Couchbase in 50 use cases company-wide, including their user profiles. So think about that. Think about how many people use LinkedIn and how they've grown over the years, and Couchbase has helped them do that. PayPal manages over 1 billion documents and 10 terabytes of data last time that we checked with Couchbase, while also processing millions of user analytics and updates per minute. eBay switched its key value store and document database to Couchbase to support over 1 million live e-commerce listings. Louis Vuitton, 400 stores, 12,000 salespeople running on Couchbase mobile. Cars.com, on-premise, in cloud scaling. Cisco, they moved, I think, a video management platform to the cloud to support 11 plus billion user sessions per year. Concur uses Couchbase. If you've ever, scheduled a travel with maybe your company, maybe you've used Concur before. They use Couchbase for high-speed caching, enabling performance across its business apps. Equifax, FICO, and Intuit all use Couchbase. And I'm sure around tax season and things like that, it comes in handy. Equifax specifically uses our multidimensional scaling to provide 5 millisecond response times for 1.5 billion constantly changing records. And then some I guess, notable other companies: Pfizer, GE, Cvent, DirecTV, Cox, Comcast, Amadeus, McGraw-Hill, Nielsen, Ryanair, Shop.com, Staples, Tesco, Super Evil Megacorp. Had to throw that one in there. And one of the reasons, some of the reasons I kind of mention these things is that as developers, and some of us starting out, we may not focus a lot on the database, and we may not learn all the different options that are out there. But you really can increase kind of your value as a developer by maybe not learning these things super deep, but having a really good idea of, maybe what the difference between Couchbase and something like MongoDB or Arango or Rethink. Why would you use one of these databases? Why would you use them instead of a relational database? Can you explain that? And then also, do you know how, at a very basic level, to work with some of these databases? I just think it's super important, especially as things get a lot more complicated in our roles as developers. We kind of span more full stack, and that's happening. So that's been happening for a long time. What are some of the benefits of using JSON? I mean, they're fairly obvious, right? Less verbose and lightweight. It's faster, readable, widely accepted data format. Simplified integration with the front end, I think, is one of the most important. So as I was saying before, kind of the ability to kind of have a very similar data object traveling across your wire from the front to the back. So on Couchbase, how is data stored? If you've ever used MongoDB before, you have probably a pretty good idea of how Couchbase is. So we have something called buckets, which is just like a database. It's kind of equivalent to a database, whether it's on the relational database side or on a other document database. They might call it a DB, we call it a bucket. Then we have scopes and collections. So scopes you can think of as kind of like a namespace, whereas collection could be analogous to like a table. And then your actual JSON document is like the rows of your table. So just a really quick kind of overview of what that looks like when you go from a relational database over to a document database. We have a place to fit all these things, and it's not a lot to keep in your head to kind of remember, like, oh, what are scopes and collections used for, and when would I use one versus the other? So also, the data access that we have is called Nickel, and that's basically just SQL. It is an ANSI standard version of SQL that is made specifically for working with JSON documents. And a little bit later, I'm going to show you a few of these Nickel examples of like how to query this database. And one thing that you're going to realize is that it's very similar to the SQL that you already know, with maybe a few keywords being different. Like you might use a nest or an unnest, which you would probably never use in a SQL for a relational database. I guess unless maybe they're using some type of a document data store also, which potentially you might have something like that. Relational versus document schema. So there's a misconception. Just because there's no formal schema does not mean that document databases are not structured. We have schema on read versus write. So any document can be stored. Really, you can chuck any information you want into a document database. With something like Couchbase, we have this query engine that allows you to kind of return that data in a more schema way. So you might have a document that has relationships with another document, and even though they exist as separate documents in your database, you can kind of return them and specify the schema with that SQL. Again, understanding the trade-offs of relational versus NoSQL databases. Know your stuff before making your choice of database. This is the point where we're going to get into JSON data structures and talk a little bit about that before we get into what an ODM is and what Ottoman JS is. But this is all kind of information that you, if you were new to a document database or new to working with ODMs, that you would probably need to know. So embedded documents are very important to understand kind of what those are. Here we have a basic, it's an address, but it has an object inside of its value. So its value is another object. So this is what I would refer to as an embedded document. And on a document database, you have the choice of whether you actually include that object right there in one particular JSON file, or whether you put it into another file and link to it with a reference. The advantages to kind of keeping it all in one document is that you have a single atomic KV operation, key value operation. So what does that mean? When I go to update this document, do I want it to happen all in one single atomic operation? Well, if I embed it within this document, then that's cool. We're going to get a single atomic operation. However, if I put it into another document, then there is some type of join that's going to need to be performed, and you're going to have to write your query in a certain way to be able to go and get that additional data. So if all the data is important to that document and for a majority of your needs, then you should probably embed it and typically let your application or your API kind of determine, like, how is your API serving up that data? Well, maybe that should play kind of a role in how you break up the data. With the document database, you get to choose the level of normalization. Repeated data is not always bad. So if you find yourself repeating some information in one document to another, that's not always a bad thing in a document database. In fact, it happens quite often. Disadvantages to keeping like these objects inside of the parent document is that maybe it's an array of objects and that array is huge. So documents can become very large and lead to refactoring down the road, which can cause a big disruption in your, if you're rapidly developing an application. You could end up nesting a lot of subdocuments. And basically that is where, instead of just one value for address here, what if street for some reason were, an array of 3 different strings? Well, that would be kind of a nesting of kind of 2 levels at that point. If you start to go past 3, you need to really think about what you're doing and should you have that many documents nested, because sometimes the operations that the database will allow you to perform, some operations won't let you go that deep. I know that if you want to update a document with our ODM, you can only update the value of address. So if the address has multiple items deep in it, that can be a challenge. You have to get all that information before you submit that update. Otherwise, you need to use some type of a subdocument operation, which can lead to just additional work and additional coding on your part. Steadfast rules for embed versus reference. Like I said, try to embed rather than reference a document when you can. Reference documents when they're too large for a parent document. 20 megabytes is the limit at Couchbase. I think for Mongo, it's in the 10 megabyte range. Both of those give you plenty of room to store data in your document. Parent document queries, if they rarely use the information, then why are you sending it over the wire? That's when you might think about referencing a document. Related data in another document will require some type of a join in a query. We went over that. Yeah, so those are some of the pros and cons of kind of using embed versus reference. And if anyone has any questions about JSON data modeling, I do have a lot more resources, which I'll be showing right before we get into Ottoman. So what I want to do now is I want to go into document relationships and talk about kind of one-to-one, one-to-many, and many-to-many. And we're going to have just a couple of these examples. So what is a one-to-one relationship? So a primitive value like this name here in this document that you see at the right, the name member of this object has a value of Sheraton Agora Hills Hotel, a basic string. That is a primitive value, and that is a one-to-one relationship. So, that's the easiest way to think of one-to-one. Now, the address that I showed you before, that's an embedded object, but it's also, if you had a related document, that could still be considered a one-to-one relationship. because you have an address, you have an object that's that is its value, but there's only one of them, right? There's only one with a city, street, state, and zip, and that's it. Now, if you wanted to relate that document, it's very easy, no matter what document database that you're in. So basically what you do is you take that embedded document you can see on the bottom here and just put it in its own document. And that document's going to have a key. So for the address value on the parent document, we are just going to provide that ID so that when we do make queries and joins, the database knows how to go and look up that other document. So in a one-to-one relationship, like I just showed, this is kind of how you can think of that when you use that ID in the parent document. It is just referencing another document in the database, making it available to query. Nickel, again, is our SQL for JSON. It's a declarative query language, and it's optimized by our query engine. And this is a bit what it looks like. So NoSQL databases have been out there for a long time. Each have created their own query language, and this is what we use at Couchbase. The concepts are the same as regular SQL for the most part. Even Don Chamberlain, who is the author of the SQL, is a huge advocate for Couchbase and the Nickel query language. And the ANSI version of SQL affords for being able to query documents as well as relational data. So you can use SQL for both. And that is exactly what we do here. We want our developers, when they're coming from another platform, another database, to be able to use as much knowledge that they already have. And so as you can see here, about the only thing in this query that you may not have seen before as someone who's used SQL in the past is maybe this on keys. So the way you can think of this here is that we have a hotel, and we have an address like our sample before. And what we want to do is we want to tell the query engine that we want to join this hotel on the key that is in the hotel.address. We can specify more like where the hotel type equals hotel or where the collection equals hotel, right? It kind of depends on whether you're using collections and scopes or not. And then where this hotel ID is 1000, you can instead of getting multiple hotels back with all of their related documents, you can get just one back. So hopefully that makes a little bit sense. Hopefully when you look at a query like this, you don't say, oh, something new I have to learn. Instead, you say, wow, this is a lot like something that I already know. And the resulting document from this Nickel query here on the left would be the same document that we were looking at originally. However, the cool thing about this is that we have put this address into its own document, into a separate JSON document on the server, which if that's the decision you've made as a team for these documents, and that's great. Otherwise, you can just embed it. By the way, if you were to embed this and it would be in the parent document, you would not have to use any type of a query. You could just do a simple KV operation, tell it which hotel you want, and it'd give you the entire document back. But again, when you put that address into its own document, you're going to need to do some type of a join. So next is a one-to-few relationship. This is very similar to what we went through before, so I'm just going to breeze through it, but it's kind of the same idea as a one-to-one relationship where you have something maybe in another document, but that other document has multiple documents inside of it. And you can still join them just with the same kind of pattern as we did before, just applying the ID in the addresses value so that you can query that. And again, query is going to look a lot the same here as the last one we looked at. In fact, I don't think that there's any change in this one other than the fact that we're calling it addresses now instead of address. And the reason I call it one-to-few is because that address value has a main and a shipping inside of it. This is, so here is kind of a non-ANSI standard Nickel statement. And then here we have an ANSI join. So this query on the left here is fully ANSI standard compliant. So again, if you understand what ANSI standard compliant SQL is, you can come over and you shouldn't have a problem using it. A lot of the things that you can do in any other database you can do here, or at least you can get yourself 90% there, and maybe just have to learn a new term or something. Finally, one-to-many relationships. So this is where you have a situation where you have like a hotel and you have reviews, and the reviews just keep coming in, right? As long as people are going to continue going to your hotel, they're going to continue to submit reviews. And so this, the reviews value for this document is an array of many objects. And it's not just a few, it's not a predetermined amount. It is an amount that grows. So you have to think to yourself, how is this going to grow over time? How is this going to scale? Should I keep it in the parent document, or should I break it out into its own document? If you keep it in the main document, you can do a very simple key value get operation like this, where from our SDK, you say collection.get, pass it the key of the document you want, and everything comes over. When we start talking about Ottoman, if you'll notice right below all of these basic key value operations, I have kind of the equivalent that you would do inside of Ottoman. So for a basic get, it's going to be called find by ID. When you insert a document, you're just going to be calling save on a model that you have in your API application. Upsert is basically a replace by ID, whereas replace is update by ID. It's kind of weird, but in our ODM, basically when you're doing an upsert, you are replacing a document by ID, and when you use replace, you are just you're using update by ID. And I'll show these examples actually when we look into one of the controllers. It'll make a little bit more sense. And then, of course, you can remove things as well. These are all very simple KV operations. They do not require a query at all through our query engine. And they're super highly performant. When you can do a key value operation, you always want to try and do that. That's one of the other reasons why keeping everything in one document is typically a good idea, because you can do more key value operations than actually getting the query engine involved. Besides these examples, you can also read or mutate documents using things like lookup in or mutate in from our SDK, again, allowing you to do sub-document operations. And you can even return data from that update in the return value on this, which is pretty cool, because normally you'd have to make a whole nother call. Now, related documents in a one-to-many fashion. And as you can assume, it's very similar to how we were doing before. But instead of just having one key as the value for one of the members of your object, you're going to have like an array where each item of the array is a key out to a different document. So let's say that you get a review from Elon and Mark from Facebook, and potentially even a couple other ones. And now you have this document which has these reviews, and they all have these relationships over to other documents. So you can think of it kind of as a mental model like this. And then, of course, you can do a very similar nickel statement as we saw before, a query. And what that will return you, even if you have these documents stored in other documents, it will return it all as one single document. And again, our nickel query hasn't gotten too out of hand here. Still looks very similar to the ones that we were using before. Finally, the many-to-many relationships. I'm only going to show the bound here. I actually don't have slides for the unbound, but I can talk about it a little bit. So an airport can have many airlines operating, and similarly, an airline can operate at many airports. So if you want to place a reference array on both sides of the relationship, that's okay. Just like we talked about before, you have this array and you have the values for each one of those items in it is a link out to one of these other documents. So not fearing an ever increasing number of references that would exceed your size limit for your document, this could be a good way of doing that. And here is kind of the result of going and fetching one of those documents using a query. Basically, we are using an array function inside of the nickel query to be able to kind of go through the airports, that each airport in airports, and list them out. And still a pretty simple nickel query. And as you see the result on the right-hand side, it all comes out as one document, very nice and pretty there with just the airport names. However, if you wanted to include specific information, you could get creative with the select and maybe provide other information about the airline inside of this array. So of the stuff that I just went over, I have some resources for that portion of the talk. And it is at tinyurl.com/json-data model. And there you will find an entire repo with all of the, not only all the nickel queries that we just went over, but even some other ones, as well as a fully operational demo with our Node.js SDK. However, we want to go a step further. We want to get a little bit more benefit, a little bit more abstraction over that SDK, and we want to use an ODM called Ottoman.js, and that's what we're going to get into next. But I just wanted to show this slide real quick. I will show it again. I will also have some more resources available for you in just a few moments. So object data mapping, that is what something like Ottoman.js is doing. Where does it fit in? So this is kind of like your normal JavaScript stack. You probably have like React as a front end. You're using Node.js on the back end. You're deploying to something like Heroku, but your Express framework is using like a Node.js SDK to reach out and talk to our database. So Ottoman fits in kind of right there in your Express application or your Nest application or what have you. And what it is an abstraction kind of over our Node.js SDK. And it helps you to reduce the boilerplate that you would normally have to write around basic CRUD applications. So Ottoman.js we're releasing a new version, probably here in September. We're currently in beta 2. It's available up on NPM. And you can get to our docs through v1.ottomanjs.com and v2.ottomanjs.com. V2 goes to the same place as ottomanjs.com, and that is the most recent version of our beta. So why Ottoman? Why bring in an object data mapper whenever you already have something like an SDK that can allow you to access the database? So abstraction between application object and the application object in Couchbase, taking control of your data by applying some type of a schema to it. Like I said, a document database doesn't require you to have schema when you insert, but your application, you may want to create a schema, create validation, manage referential integrity and relationships. You can do that with our models and schema. It has native methods for storing and retrieving objects. So you can, on your model, you can call it .save and that will insert your data. You have support for multiple indexing strategies. I'll show you one in the demo. We also have other indexing strategies that you can create very simply with just a few lines of code, which means that potentially you could start up an Ottoman project with your database running and not ever have to go into the database and create any indexes yourself. Although it's very good to know how to do that. With Ottoman, you can potentially start out without not doing that at all. Have Ottoman build those indexes for you. You can make code reusable with plugins and atomize model logic with middleware, basically just breaking your models up into tinier pieces and importing them into different areas of your application. Like I said, validators and also support for custom data types, which works actually pretty well with validators. You can create a whole new data type. I'll show you an example of that. And in that data type, you're going to have typically some type of a casting or validator to make sure that the value that they're giving adheres to that special custom data type. Well, it looks like a couple of my images are not loading here. What I was going to show you here, they work on my other screen, but they're not working here. This is very weird, but it's not a big deal. Some of the things that we can go over are custom data types, the query builder, and application configuration. Rather than go over the code with you on slides like I was just going to do, what it might be better to do is for us to jump into a working application, since we're running a little bit short on time, and walk through an entire Ottoman JS application and really figure out what this can do for us and how it can help us to organize our project, work better as a team, incorporate types and even TypeScript into our APIs that are being built on top of Couchbase. So with that, we are going to get into a code demo. See, as you can see here, my slides and my images are there, but they are not showing up on the preview for some reason, which is very odd. But let's go straight into the demo. First of all, we're just going to take a walkthrough and get a lay of the land. And I'm going to increase the font size a little bit here and get rid of my terminal for a few minutes until we start the project up. Let's go ahead and close that. So start with the package.json. In order to use Ottoman, which is an ODM, think of like in Hibernate or some type of micro ORM that you've used with a relational database. This is similar to kind of what an ODM is for a document database, but an ODM plays a little bit bigger role in the application layer to provide additional schema and validation and all the things that we talked about. In order to import this and use it into your project, all you have to do is install your framework of choice that you're going to be building your backend in, as well as Ottoman. Currently, we are on beta 8, and we're about to release the version 2 within the next month. Outside of that, I have some dev dependencies here, which just allow me to work with TypeScript in my project. So nothing to see here really, but you will notice that we're using TypeScript in this project, and Ottoman and our Node.js SDK are configured to make it easy to work with TypeScript. So this is a global configuration for Ottoman. In this application, I'm only connecting to one bucket in our database. So we have the bucket name there, Travel API. And what we're going to be doing is building an API that allows users to insert, update, create, read, update, and delete airports, airlines, hotels, and flight paths. Here we have a basic connection string and bucket name, as well as username and password. This stuff, you could use something like .env to and environment variables to provide that, but I just wanted to make it very simple for the demo. As well, you can set up default scope names and collection names for your data. So again, scope is like a key space. So we're calling ours travel. Basically, we want all of our documents that we create to have a scope of travel. And we're going to set the default for collection name at actual default. Now, this is the default. If you don't actually provide this, this is what you're going to get anyways. And although we're not going to be using _default for any of our documents, we're going to go ahead and set it here anyways, just to be verbose. And then inside of our models, we are actually then going to specify what the collection name for each of our different hotel, flight path, airports, and airlines is going to be. So that's a pretty quick overview of just the config. There's some more things you can do in the config, but this is the basics. Then we have our index and our app.ts. So one of the reasons why you want to separate these files, one is testing. So if you have your application set up with basically all the boilerplate for getting your controllers and your routes and everything up and running in its own app.ts file or app.js if you're not using TypeScript, and then exporting that out, that's going to make it a lot easier for you to pull that into a testing suite and use something like Supertest to test your endpoints. We're going to use Postman today to test some of these and kind of see how things work. But as you can see here, all that we're doing is we're importing that app. We're importing the Ottoman global config and each of our different controllers. We will look really quick. We have a shared file here. Only 2 of these are specific to Ottoman, or these 3 are specific to Ottoman. These other 2 here, these are just basic Express setup, project setup. So we want to have a controller type and tell it what our controller is going to have. It's going to have a router and a path. The router will use express router, and then we're going to set custom routes for each one of our controllers. And we're just going to put all those here so that for hotels, flight paths, airports, and airlines, they all are going to have a get all, get by ID, post, patch, put, and delete. Next, we have one schema. We're going to see more schema here in a minute, but this is a schema that we use in multiple models. So since we do that, I went ahead and created a file here for it so that we can import that wherever we need it. And then here we have created a custom type. So without going too crazy into this one, what I will tell you, what are we doing here? We are creating a special type called a link. So you can see here that the type, the Ottoman type is going to be called link. And what is it going to do? Well, if someone submits text for that member of a certain object that is using this type, it's going to try to get it to conform to this regex here, which basically checks to see if it's a valid URL link or not. If not, it is going to throw a validation error. It's about all we need to go over there. It's although this is a little bit verbose, this is the kind of pattern that you would do to create one of these. We use a factory function to create and register these. But if you need custom types, then you can totally do that in Ottoman. We also have a make response here. So this function will always respond to the client. And it just allows us to reuse our try-catch logic rather than handling errors. It also reduces boilerplate in your controllers. So with all that out of the way, let's now get into really quickly the hotel model here. So as you can see here, when we create a model, we have a validator that we've created. So for when someone submits when someone creates a new hotel, the phone number is going to use this validator here. And this is how we set that up with Ottoman. And this just lets us know that it's going to need to be a type of string and that the validator is going to be called phone. And this is where we set up that phone validator. You can set it up inside your file here. You can set it up in another file if you want to use it in multiple controllers. Also, we have the ability to set up indexes very easily here. So here we are indexing to find a hotel by name or by city. And we are using a nickel type of index. This is specific to Couchbase. So it just means that it's going to use the nickel query engine under the hood to basically register these indexes with Couchbase. Finally, here you can see on our model where we're creating our model, we're telling it, hey, this is the schema that we want to use here. This is how we want our object, hotel object to be to conform to. And also we want it to be created under a collection called hotels. Pretty simple stuff here. Then we have our controllers, which basically just have a post, a get all. And you can see here that we are doing very, very basic, simple stuff here, not a lot of boilerplate. And that's what Ottoman's helping you do. So here I'm able to save a hotel simply by receiving that hotel in the request and then pretty much just calling hotel.save. That's all there is to it. That's going to insert that hotel document into the database so long as the phone number matches correctly and any of the required fields that we've selected have not been left out. We also have the ability when we're doing a get all to not write a single line of nickel query at all. Instead, you can create some options for the find. And then I can say hotel model.find. I can pass in that filter, which basically is just setting up some limit and some skip options. And then also a filter, which is going to go look for the city where the value passed in through the search is basically like a certain city in the database. So if we were to pass in San Francisco, then San Francisco would be the value right here. These characters on the outside here, the modular characters here, these are just going to say as long as this string is contained either with anything to the left or anything to the right of it. That's basically it. The rest of these here are basic key value get operations. So I want to move on to some of the other models and controllers really quick. We'll just breeze through them. So here we have airlines. We have specified the collection name to be airlines. We are setting up an index here to be able to search by name. Very simple schema. Controller is nothing different than what we just saw before. Same thing with the airports, basic model, basic schema. We are using this geolocation schema from the shared folder over here to define that schema. But other than that, it's a very basic model, very basic controller. Again, nothing different than what we've seen already. So the next thing I want to show you really quickly is the flight paths. And this is the last one we're going to go over. So what we have here is, this is the schema for our flight paths. So what this is going to tell us is when a specific airline has a number of flights on particular weekdays. So here we have, as the schedule will be an array of flights, and then you will have the number of stops, like Boeing 747, how long the flight is, what's the source airport and what's the destination airport, and then what is the airline ID. So here we are creating a relationship to an airline from this flight schema, and then also we are telling it what is San Francisco the starting point, is LA the ending point. And this is where you get into one of our cooler features of Ottoman, which is the query builder. So what happens here, and I'm going to point out a few things real quick. I am using two different kind of methods of building this query. I am using this method chaining here, where I define the from as part of the query, and then I chain on the select statement, the join statements, and the where statements. And then for like order by, I didn't do order by, but I did limit and offset as parameters. So I could have gotten rid of this and only included them here as these function chains, or I can create them as queries, as parameters and pass them into the query, or I can do both. So I can do like a mixed mode. So you have a lot of kind of leeway here to kind of build these queries in whatever way that you like, and use whatever method you like. And at the end, you're basically just going to call connection.query and build that query. And you're going to await it. And that's going to go ahead and get that. It's going to build a nickel query, send it to the database, and you're going to receive the data back. One other cool thing that you can do is you can console.log out this query.build, and you can get back the actual nickel statement for debugging purposes, in case maybe you've missed a backtick somewhere, or who knows, a parentheses or something. You can actually go ahead and debug that query. Really quick, we'll just spin it up real quick and just go ahead and make sure that this guy is working. And the only thing we're going to do right now is we're going to call the flight. So we're going to go ahead and try and get this. So here are all the flights for United Airlines. We have day 0, 1, 2, 3. And you saw that I set up the skip limit with parameters instead. So if I wanted to skip 1 and limit it to 2 and then send it again, we can see that that's working okay here. As well, hotels, we saw how all this works. With a put, I was going to show this. With a put, you have to include the entire document, which is kind of a hassle. So we also have the ability to do stuff like a patch, where you just send over the exact members that you want to replace. And Ottoman takes care of, figuring out where those items are in your document and not replacing anything else, and only replacing these items here. So with that kind of concludes the end of my demo, but I do just want to really quickly bring back up the resources for this talk. So again, I have a tiny URL here to go look up. You can go this is a repo for the JSON data modeling stuff that I just showed you. And then also the application that we just looked over is at tinyurl.com/Ottoman-API. And again, my name is Eric Bishard. I'm a developer advocate here at Couchbase. You can reach me through Twitter or GitHub at HTTP Contact me on LinkedIn. And with that, I want to thank you very much for having me out and letting me talk to you guys about Couchbase, JSON data modeling, and our ODM called Ottoman JS. If anyone wants to contribute, they can contact me on Twitter or just go find our GitHub repo and submit an issue. Thank you very much.
Hey, I hear I'm live on the internet. Not that I'm ready to start yet or anything, but we'll be starting soon enough. I'm waiting for the clock to officially tick over from to 2:10. So meantime, I'll scratch my forehead. Is everyone having a good conference so far? Hopefully you are. Hey, there's John Ryan that just joined Track 1 Questions. I know John. Welcome. Good to know. Good to know. For those watching the video and not actually in chat here, John said it's been a fun day. So a fun day is a good day, and a good day is a fun day. That's fine, John. It was recorded for posterity, so it's a fun Bigfoot session. Yeah, John has apologized for missing my Bigfoot session earlier, but it is on YouTube, so you can go watch it at your leisure. And I have given it other places as well, and will continue to give it as long as people let me. So there's a fun talk on understanding how to use RediSearch to get to data in hashes and JSON documents, mostly hashes. Did someone see a Bigfoot in Ohio? Actually, Ohio is prime Bigfoot territory. The Pacific Northwest gets more sightings, but Ohio and southeastern Ohio specifically gets a lot of them. I think it's because I think the guy who organized the BFRO, I think he's based out of Ohio, or there's someone that's part of one of the research organizations that run Bigfoot based out of Ohio. It's either that or Corey Shields. So Corey Shields might be responsible too, if he's out there listening. By the way, Dan, Bigfoot is capitalized, capital B. It's his name. There's one of them, and he gets around. So. It's actually odd that the Bigfoot's capitalized. Now I think about it, it's like, is there a Bigfoot? It's just the one Bigfoot. That's his name as his title. Is the plural of Bigfoot big feet? These are important questions that have nothing to do with my talk that's coming on here in 1 minute. This is about Dungeons and Dragons, where there are no big feet. Actually, it's about graph databases. But. I think Bigfoot is a singular person, John, and I mean, he's got a name, right? It's Bigfoot, John Bigfoot. Yeah. There's also that one comedian, I can't remember who it was, that said the really scary thing about Bigfoot is maybe, the pictures of Bigfoot aren't blurry, but Bigfoot is actually blurry. And that's extra scary and creepy. So we're at 2:10 right now. So I'm going to go ahead and get started here. Let me reset my timer on my PowerPoint so that I don't go over. There we go. And welcome everyone to Dungeons, Dragons, and Graph Databases. This is a talk about graph databases with a fun Dungeons and Dragons theme. My name is Guy Royse. There we go. I'm a developer advocate at Redis. I tend to talk about this slide and say there's three things that matter on this slide. One matters to my boss, one matters to me, and one matters to you. The thing that matters to my boss is the Redis logo right there. I work for Redis, he works for Redis, and Redis is well, it's where Redis has developed the software product. And we're going to be looking at graph databases today. Redis Graph is a particular product that we have as well. You tack it onto your existing Redis installs and installations, or do your own thing with it, or use a cloud product, whatever. You can play with these graph databases yourself. So that's the thing. That's a part of this sheet that my boss cares about. There's part that I care about, which is my Twitter ID. I want you to follow me on Twitter if you don't already, because I get value out of having that number be big. And when it goes down, I feel like I'm a terrible person. So please help me feel like I'm a good person. And there's the part you care about, which is this URL right here, github.com/Guy Royse. That is where all of the code and slides and examples and all that stuff for this talk are going to be. So when you get done with, when I'm done talking about graph and you come to the conclusion, as you should, that graph databases are awesome, you will have some sample code to play with and something to get up and running. That's the place you want to go. So I'm also, in addition to being a developer advocate, I'm a gamer. I'm a player of Dungeons and Dragons. I've been doing Dungeons and Dragons for, I don't know, since the 80s. I mean, for a really long time. And so I thought I would share my character sheet. This is a little more about me. I am a neutral good dwarven bard. I have an armor class of 11. I've got a little bit, I'm not wearing any armor, and my dex is low, but I get a +2 to my armor class because I have got a thick skin because I do public speaking for a living. You can see there, my abilities are kind of, my physical abilities are kind of meh. My intelligence and wisdom are low. I'm actually not very smart nor very wise, but I have a high charisma. So this talk will be everything that you think it'll be, all sizzle and no steak. And as a player of Dungeons and Dragons, I have a particular problem. It's a problem a lot of us have, right? I've got this dungeon full of rooms, and these rooms are full of interesting things. They're full of monsters, which I can kill to get experience points. And they're full of treasure, which I can gather to upgrade my equipment. And I want to get these things so that I can level up my character. And how am I going to solve this problem? I want to find the best way to go through this dungeon, the most efficient way to go through a dungeon, get the best monsters, get the best gold without being distracted by empty rooms, making sure I do this in an appropriate order so I don't go to the toughest monster and get my butt kicked right out the gate, but I'm also not bored just, killing a bunch of were-rats or something. And I'm like, well, I'm a programmer. I can solve this problem. I'll just make a database. And I'll have all the rooms, and I'll have all the monsters, and I'll have all the treasure, and then I can query that database, and I can figure out how to the most optimized fashion for me to explore my dungeon. And I can do that, of course, using sort of the default answer when you need a database. Like the most common answer when someone says, "Hey, we need a database," is, "Well, let's use a relational database." It's sort of been the default answer for, oh God, I don't know, since the 70s or maybe the 80s. I remember when I was first early in my programming career, we would use Oracle, and Oracle's little SQL command line tool would say copyright 1979 on it. So relational databases tend to be the go-to. It's the first thing you think of. There's been a lot of movement in NoSQL, thinking about other databases other than relational databases, but I could use a relational database to model this data. I would have rooms and treasures and monsters with tables and rows and columns defining all these things. It would be a perfectly adequate solution. But I'd like to do a different kind of database, a NoSQL database, a graph database specifically. And a graph database is a different kind of database. Do I want to use a relational database to solve this problem, or do I want to use a graph database to solve this problem? This talk is going to be a talk where I explain what the heck's a graph database by comparing it to what a relational database is and showing you how you can do comparable things and building up on these ideas. So that's what we're doing today. We're going to explain graph by using SQL as an example. Sound good? Good. So the first question is, what the heck's a graph database? Except that's not the first question. The first question is actually, what the heck's a graph? A graph is, well, it's a bunch of vertices that are connected by edges. You can think of it as a series of nodes that are connected together. They can be used to represent all sorts of things. In this particular case, I've got a 20-sided die. This 20-sided die right here has a vertex, the point, the corners, and it has an edge, which is, well, the edge. And the edges connect the vertices together. But a graph doesn't have to represent just like a Platonic solid. It doesn't have to be one of these guys right here, right? It could represent, you know, the relationships of a bunch of humans. You could have a social graph. Facebook has a social graph, right? You could have some sort of logistics mapping where you're saying, you know, you're keeping track of where goods go through, you know, different points of contact. You could do contact tracing. That's a graph. That's a type of social graph. It's a disease graph. All sorts of things. And they don't have to be constrained to any kind of dimensionality, right? You know, this is, you know, it requires 3 dimensions to represent this 20-sided die as a graph. But graphs that we might conceive of, like the social graph, is going to have a much higher dimensionality. Graphs are actually really intuitive once you start diving into them. So I've talked a lot about them, but I'm going to show some more pictures. Well, maybe not. I'm going to show some more pictures. Here's a blank screen. The simplest graph is the null graph. A null graph has no points. It has no vertices. There's nothing here. There's no relationships either. There's just nothing. There's some argument as to whether a null graph is actually a graph or not, but ultimately it kind of doesn't matter because there's nothing there. It's kind of like saying, is null a thing and is it different from undefined, right? Null graphs are just null. There's nothing there. So let's make something a little more interesting. Let's add some nodes or some vertices to our graph. And so we now have a bunch of nodes. They're just points floating out in space. I put letters on them so we can identify them, but there's no other meaning to them other than that. And they've got colors as well, but they're just a bunch of points floating out in space, and they could represent all sorts of things. To make this graph a little more interesting, just, you know, this is a perfectly valid graph. It just doesn't have any relationships. It's just not a very interesting one. So let's add some relationships to our graph. And now we're starting to get things that might convey some information and have some meaning to us. We see that nodes D, A, C, and G are connected, and B and F are connected to each other. And we're starting to see some meaning in this graph. This graph, however, is, well, it's what you call isolated, right? So node E is all by itself. It's isolated. It's not connected to anything else. Nodes B and F are isolated as well. They might be connected to each other, but they're not connected to the larger graph. And in fact, any subgraph that's not connected to the rest of the graph is isolated. So even this main part of the graph, as you might think of it, is an isolated portion of the graph. This is just, you know, you got little islands. Islands are the isolation pieces. You know, if you got a subgraph that's not connected to the larger graph, it's isolated. So parts of a graph can be isolated. Let's connect all the nodes, and now none of the subgraph, there are no isolated subgraphs. This graph is referred to as being connected. What connected means is that every node in the graph has a path, either directly or through another node, to other nodes. So nodes D and F are connected, just not directly. You can go through a couple paths. You go D, A, B, F, or you can go D, A, C, B, F, right? All of those would work. Those are paths that you could take through this graph. You can actually have, in addition to, you know, isolated subgraphs and a connected graph, I suppose you could have a connected subgraph as well. You can have a fully connected. The idea of fully connected, this subgraph here is fully connected of A, B, and C, means that every node in that graph or subgraph has every possible connection it can to all the other nodes. So node A connects to the other two nodes in the subgraph, and node B connects to all the other nodes in the subgraph, and node C does. You've seen these diagrams where you have like 20 nodes in a circle, and then they basically make a crisscrossy star pattern. That's a fully connected graph. Usually they're used to show like a network diagram. It's the compute the number of connections in a network with 20 nodes. Well, that's it. That number of connections is fully connected. That network is fully connected. So you've seen this circle with all the cords going across it before. That's what it means to be fully connected. This graph is undirected. The nodes here are related. We know A and B are related. We know B and F are related, but there's no direction to them. There's no additional information that shows the nature of that relationship or the direction of the relationship. We can represent that by arrows. And now this is a directed graph because A and B are related to each other in a particular way. Examples of things that might be meaningful in a directed graph, in a social graph, could be following each other. So if, for example, I follow Bhaskar on Twitter, that's a directional relationship. I am following him. Now, Bhaskar follows me back, and so there's another relationship going the other direction. Or Bhaskar follows me. Or, you have the relationship of a mother to their child. The mother bore that child, and that has a natural direction to it. You can use these directed graphs to represent those sorts of structures. On a graph, we can talk about the degrees of nodes. So a node could have degrees. What's a degree? It's actually just the number of relationships that node has. So node A here has a degree of 3 because it has a relationship with A, C, and B, or D, B, and C. You can also, in directed graphs, measure the out degree, which is how many outbound relationships it has, and the in degree, which is how many inbound relationships it has. So you've got degree, in degree, and out degree. These are ways of talking about graphs. And probably the most important thing is and I sort of mentioned this earlier, you're not confined to 2 dimensions or 3 dimensions or a number of dimensions. Anything can connect to anything any way you want. So here we've got A and C connecting to each other, back and forth, each direction, and same with A and B. Node A is connecting to itself. You can have a node connect to itself as well. There just really aren't any rules. They can crisscross and go over each other and everything. A graph database is where we take this graph structure that is representative of something that we care about, and we start laying data on top of it. It stops being a tool to reason about a problem, and it starts being a tool for storing information about a problem. And so each of these nodes could represent a type of thing in the graph, like rooms, monsters, and treasure. And on those rooms, monsters, and treasures, you would have a label so that we know they were rooms or monsters or treasures. And you would have properties, like perhaps an ID or a name. And so there's more data about them. We've got data overlaying our nodes. And our relationships can have data as well. They can have a type. So this is just a string for us humans to read. This isn't a magic thing. It's just the room contains the monster we decided to call it contains because that's our problem domain. And actually these arrows can have properties on them as well. These relationships can have properties as well. And so we lay this data over top of this graph structure, and that's what a graph database is. Just to sort of sum up some of the things in case I missed a couple points here. Nodes in a graph database represent items. Usually they're nouns. They can have labels, plural. A node can have more than one label. They can have attributes, which are these properties, these key value pairs associated with them. And they can stand alone. Just like in any graph, a node does not need relationships to exist. Paul Simon may have said that no man is an island, but the graph database disagrees with him. And so you want to do a solo adventure, you're happy to do that. These nodes can just be out there by themselves. The relationships, on the other hand, represent a connection between two nodes. And instead of having a labels, they have a type. They only have one type. If you have another relationship with a different type, then it can go in the same direction and be parallel to it. It just has a different type. They have a direction, and they can have attributes as well. So like the leads to attribute might have a distance of how long it is along the corridor from room 1 to room 2. But importantly, nodes can exist without any, they can stand alone, but a relationship can't. So if we have 2 rooms that are connected and I delete one of the rooms from the database, all of the relationships and the data in those relationships goes away. The nodes they went to are still there. So like if you think about that in terms of like this 20-sided die I have here, if I got rid of this point right here, all these lines going to it would go away. And so then you would have a flat surface there. But the points themselves they're connected to are still around. So if you delete a node and it has relationships, the relationships go away as well, because 2 points determine a line. And if you don't have 2 points, you don't have a line. These well-designed graph tends to read like a sentence. The room contains a monster. Specifically, it reads like a sentence with a transitive verb. The nodes are the nouns of the sentence, and the verb is the relationship. So the room, subject, noun, contains transitive verb, and monster, direct object. So the room contains a monster. You can actually flip the direction around, I suppose, and put it in the passive voice and say the monster is contained by a room. But the passive voice, as my English teacher told me all those years ago, is to be avoided by zombies. So yeah, so that's sort of the theory around graph and graph databases. But let's make this real, right? We're developers. Show us how to actually write code. We still have our problem. I still need to find the rooms with the best monsters and the best treasure so that I can power game. Kevin Bacon does have a lot of degrees, John. He has that node is I wonder how many. Yeah, that's probably a lot. It's actually an interesting question to wonder how many degrees an individual has, right? I guess that's the definition of networking, isn't it? But we still got this problem of power gaming here, right? And we can solve it using a relational database, and we can solve it using a graph database. And what's the code for a relational database versus a graph database look like, right? In a relational database, if we want to talk to a relational database, we use SQL or SQL, where we select some columns from some tables, and where some values are the same, we join and filter and all those sorts of things. And SQL is a well-established language. It's actually the oldest programming language that I know. It's the first one I learned in college. It's the oldest. It's the language I learned in college that I still use. Because a lot's changed since I was in college, but SQL is still out there. The equivalent, the query language for graph databases are a popular one. This was created by the folks at Neo4j, and it's what Redis Graph uses as well. It's called Cypher. And it looks a little different. It's like a cross between a query language and ASCII art. It's got these matchers, which are kind of at the heart of it, and then some other commands that in many ways are very reminiscent of SQL. So the matchers I think deserve special attention. So let's take a look at one of these matchers here. The matchers are things that match patterns in a graph. And they look kind of like the graph, right? If you look at this little bit of text here, we've got a room. You'll notice I've color coded them. So the room are dark gray. The monsters are red. And these things in the parentheses represent the nodes, which I've drawn as circles, which if you were drawing a graph, and people have drawn graphs this way forever, is like circles and lines, circles and lines. And so the query language uses parentheses to make the nodes look like circles, which is how you would draw them. This matches a room node. The colon room means it has a node with the label of room, and assigns it to a variable R for use later in the query. Colon monster matches a label, a node with a label of monster, and then assigns it to the variable M for use later. And then here in the middle, we have the relationship, and it's got a colon type as well. So it's got a contains type. assigns it to a variable C. And you'll notice we use square brackets here instead, but you'll notice that we got a dash on the left here, and we got a dash greater than on the right here. This is literally an ASCII arrow pointing the direction of the relationship. So it's room contains arrow, a monster. You could actually turn this 180 degrees around and put the room on the right and the monster on the left and have the arrow pointing left instead of right. Still works. It's exactly the same match. And these matches are used in the graph database to go through and find every single pattern in the graph where this pattern is found. That's why they're called matchers. So everywhere there's a room that contains a monster, this will match that graph. So it will walk the entire graph and find all those patterns, which is kind of cool. Let's look at some patterns for using, let's look at the basic patterns. Let's look at the CRUD operations: create, read, update, and delete. I want to create some nodes in a graph. I want to create some rows in a relational database. So if I want to create a room and put it in a relational database, of course, at first I need a room table, right? And I know that my rooms have an ID and a name. So I create a room table. And then to insert something into it, I use the insert command. So insert into rooms, ID, name. Values are the values I want to insert. So here we're creating the statue room. If I want to do this graph, for starters, I don't need a schema up front because graph is schemaless. These nodes can have any properties you want. They're arbitrary. They can have any label or labels we want. So a room could also be, say, maybe a chamber or a corridor. And to create a room with Cypher, the query language for modifying graph databases, we use the create command. And then we pass it the pattern that we want it to create. Here we're saying create a node with the parentheses there, and give it a label of room and assign it to R. And now we've got a node. And if we did just that one line of code, we would get a room node with no properties. But we continue the query and use the set command and then set a couple properties on it using that R variable. So here we've got our R and then defined, and then here we're using it. So we can create a room node and then set the ID to 1 and the name to statue room. And we could set other things, whatever we want to set on here. Boom, we've got a node. So we've created a thing. Now we can read it. To read from a relational database, this is the one you learned first, right? It's select columns from table where ID equals something. Easy peasy. To do this with graph, we use a match. And so instead of creating a node, we're going to match a node. And so match R:room. That's going to go through and find every node in the graph that has a label of room, and it's going to match them. Then we can use a where clause, which looks a lot like the where clause on the SQL statement, to filter them out, because that first line will match every single room node. It's like a select star from tables. And so we want to filter out and just get where the room ID is 1. And then once we've got that, then we need to return it. So the last command says return R, return that room where the ID is equal to 1. So match, where, return. And this pattern is going to repeat for other commands, because after once you find a thing, you might want to return it, but you might want to do other things with it instead. So when it comes time to update a room in SQL, we use update, table name, set field equal value, field equal value, field equal value, where ID is 1. And here we're setting the name from statue room to statue hall. Now the room is getting an upgrade. It's getting fancier. It's getting new statues. In graph, in Cypher, we do that same match where that we did in the select statement, or in the reading, right? We match the entire graph for all the rooms, filter where we get room with 1, and then we call set. Instead of returning it, we're going to set it. We're going to set the name to statue hall. If we wanted to add a new property, we could do that too. We could say like set r.trapped equals true or something like that. But in this case, it's overriding an existing property. So match where return, match where set, and for deletes, for create, read, update, delete the safest of all commands on your database. In SQL, it's just delete from table. Make sure you put that where clause on there, or you're having a bad day. In graph, it's match where, and then instead of returning, instead of setting, you're deleting. So it's sort of that same repeated syntax. You're always matching that pattern in a graph. And then this is a simple just match a node, but you can actually do more sophisticated matches, and we'll get into those. A note on the syntax I've been using. I've been using this match where syntax. I've sort of pounded it into your head. But you can also do a match with curly braces. So here I'm doing match r:room, curly braces, ID:1. The curly brace syntax there is exactly the same syntax you would use in JavaScript for defining object literals. We're saying where ID:1, and we would say comma name colon, and then in quotes, statue room. That would match all the rooms where the ID is 1 and the name is statue room. And so it acts as an and, just like it needs to match all the conditions. And I used the create node and then set properties on it, but you can actually use these curly braces for creating nodes as well. So I can say create me a room, and here's properties you put on it right when it's being created. And you'll notice that in all these other cases, I'm using the R because I need to refer to it. But actually in here, I strictly speaking don't. I would want to return it. But down here, I'm creating a room. I don't need to modify the properties on it. I've set all my properties to what I want. So I can just say R:, and be done with it. So, and I see John's typing for a question here. So I'm gonna stall until the question pops up here. Oh no, he stopped typing. What do we do now? I'm gonna plow forth, and I'll get your question, John. Here I'm using I'm going to create monsters instead, and so it's the same process as creating rooms. You insert into the monster table, set the values. But you can see here I'm using that alternate syntax. I'm using create :monster instead of :monster, and I'm just passing in those properties that I want. And here I'm going to create a treasure, and again the insert's the same from a SQL point of view. But I actually used a hybrid approach where I'm creating a treasure and it has the ID and the gold piece value. But then I store the variable here and then call set as well. So you can mix and match these as well. So John's asking, as room is not a defined type from what I'm seeing, that is correct. Would the create option create r::rom, where room is misspelled, raise an issue? Well, as far as Cypher concerned, that is a perfectly valid request. You will want something with a label of ROM, and so it just does it. And if you're trying to match on it, it's not going to find. It's not going to find anything. This is ultimately the same challenge you have. It's the typed versus untyped language. It's the schemaless versus schemaful schemud databases. It's the same sort of trade-offs you're making. There's nothing to enforce that you use the correct types because the database doesn't really, other than having types, it doesn't know what types are. Nothing in your code enforces it. There's no upfront thing saying these are the types that I'm going to use, other than just convention in your code. So if you make a typo, then you've made a typo, and then it's going to create nodes with the wrong type. That said, you could fix that. So it's not the end of the world. So good question. I actually get that question quite a bit. I should probably add a slide on that. So let's take a look at our relational database so far. So far, we've got just some tables with some rows in it. It's pretty straightforward. And our graph database is just some nodes floating out there in space. They're not related to each other. Each node is isolated, but we have properties and we can go look them up. The interesting thing comes up when it's time to start relating things to each other, right? It's a relational database, and the graph database is all about creating relationships between nodes. It is, I think, actually a great irony that graph databases are more relational than relational databases, in a sense. It strikes me as ironic. So let's start by putting a monster in a room. So if we want to do this with a relational database, the first thing we have to do, because we have a schema, is we need to alter our schema. We need to add a column to the monsters table to create a foreign key. And then we need to populate that foreign key by putting it in there. So here, Alice the elf is in room 1, and Bob the ogre is in room 3, the armory. We've done this before. This is a basic one-to-many relationship. Yeah, and you're right, Ryan. It could be a challenge locating a badly created room node. You'd have to see the typo in your code. You can actually go out and query all the nodes in a graph as well. So you don't have to specify a type when you query it. So you can just say match n, and it will return all the nodes. So altering a table and then updating it, right? That's how you put a monster room with a relational database. In a graph database, that's not how it works. In a graph database, we want to create a relationship as data, not as a schema. There's no schema, there's only data. And so what you do is you match the two nodes that you want to relate. Here I'm matching a room that contains a room, and I'm matching a monster. And then I create a contains relationship between those two nodes that I queried. So I match r:room, where ID is 1, and m:monster, where ID is 4. And now I've got r and m as variables here, and I can use them in my create statement and say r contains an m. So I'm creating that relationship between them. So it's actually pretty easy. You just create the relationship. Putting a treasure in a room, it's exactly the same pattern. You update the treasure table. Putting treasure in a room with graph, it's exactly the same pattern. We're matching the two nodes we care about, and then we create, using the create keyword, the relationship between them. You might be tempted to try and compress this syntax down to be create r:room, where ID is equal to 2, contains t:treasure, where ID is equal to 6. But if you do that, you're going to get duplicate nodes. It's not going to match the existing nodes. It's going to create new nodes. And so we want to match the nodes that exist and then use the variable, because it's not going to create the variable. So just a little caveat there. So our relational database so far now is a basic one-to-many cascading. Rooms have one-to-many treasures. A room has one-to-many monsters. Our graph database has some rooms that contain monsters and treasure, some that contain both, some that contain one. So like the statue room contains a monster. The armory contains a monster and a treasure. The room contains just a treasure. This is enough that we can start doing some interesting queries that are beyond just create, read, update, delete. It's Munchkin time. Let's go find the rooms that have the most monsters and have the best treasure. Or the best monsters and the most treasure. That's probably how we want to do that, right? If we want to farm all the XP, we want to find the rooms that have the best monsters so we can get some XP to level up. We can do this with a basic join statement in SQL, right? So we select the columns from the two tables we care about, rooms and monsters. And then we join on that foreign key. We say where room ID is equal to the monster's room ID. And then we can order that by our experience points descending, so that the most expensive monster is the highest XP bubbles to the top. This is a basic join. Well, we've probably all done this. To do it in graph, it's a little different, but not terribly so. Here we're doing, instead of just matching a node, we're matching a node containing a node with a relationship to another node. So we're matching a room contains a monster, room contains a monster. So everywhere in our graph of perhaps dozens of rooms and dozens of monsters, every single time that a room contains a monster, give us a match. If a room contains multiple monsters, we'll get a match for each of those patterns. So if the statue room has 3 monsters, we're going to get 3 results back. Then we can choose to return the fields we want out of all the things we matched. We don't have to return nodes. We can return the ID, the name, and the experience points. And then we can order that by experience points descending. So we get that same sort of list of tabular data out of our graph to give us sort of a prioritized list of the best monsters and the worst monsters to fight. So that's how we can do sort of comparable queries in graph versus relational. If we want to get all the gold, it's a similar sort of thing. We're just joining on treasures instead of monsters, and getting all the gold with graph. We're just saying the room contains treasure as opposed to the room contains a monster. You could do a query, a more sophisticated query, where a room contains a treasure and a monster. There are ways to do rooms that can contain treasures and don't contain monsters. There's lots of interesting queries that you can do. But here again, we're just sorting the gold piece value descending. So this is kind of interesting, right? But, so far, so good. So what, right? Besides being, a title of an awesome Megadeth album, so what, right? We haven't done anything with graph that we can't do with a relational database. Well, that's not completely true. Graph hasn't really had an opportunity to shine yet, but it's about to, because we're going to put connect rooms together. And this is where graph starts getting really different from relational. In a relational database, if we want to have rooms connecting to rooms, we have to create a mapping table where we map rooms back to rooms. So here we've got a connections table. It's a relationships table. It's actually representing the graph, right? And so each row in the rooms is one of the rows. And then in the connections, we have a to and from ID. So we create this table. The from ID is the room where it starts, and the to ID is where it ends. And there's a connection to connecting those rooms. There's a corridor. And then we need to insert into that connections table, for example, that room 1 leads to room 2 and room 2 leads to room 1. And that's how you do that. Querying this is actually kind of a pain in the butt, because with just standard SQL, you have to join against itself several times to get this to happen. And you have to explicitly say how many times you can join. Now, there are language features to do arbitrarily deep joins like that. I haven't really used them in SQL. It's kind of getting into the weeds in SQL, honestly, when you start doing things like that. When you find yourself doing things like that, what you really need is a graph database. In graph, the way that you can connect a room together is you just match the two rooms and create a relationship between them. And so it's exactly the same. The way you connect a room to a room is the same way that you put a monster in a room or you put a treasure in a room. You simply match the room number 1, you match room number 2, and then you create a relationship between them using the create command. So this creates a leads to as opposed to a contains relationship, because this room leads to another room. But it's exactly the same structure. And so now that we have what does our database look like now that we are, putting connecting rooms together? Well, the relational databases, even for this small problem, has gotten kind of complicated and hard to reason about and hard to query. Whereas the graph database kind of looks like my dungeon, right? The rooms are all connected together, they contain things, and it's really in many ways a more intuitive way of storing this data. So now that we have a fully populated graph, it's super munchkin time. And this is where graph really starts to shine. I can query a pattern, a matcher, that has an arbitrary number of hops. So here I'm saying a room that leads to a room, and there's that little star there, right? So this matches a room, this matches a room, right? So we've got rooms on either side. So we've got our 2 rooms here. And then we have a leads to relationship between them, but the star says match multiples. Go as many hops as you can to make that relationship. So this pattern matches a room that leads to a room, but it also matches a room that leads to a room that leads to a room, and a room that leads to a room that leads to a room that leads to a room, and a room that leads to a room, and so on and so on and so on, up through as far as you can go, which is very powerful. In SQL, you'd have to do some sort of recursive join. Here, you just put a star in it and it works. If you're paying attention, or if you're particularly, not if you're paying attention, but if you're particularly astute, you might have said, hey, what if I got a graph that's a circle and it's directed? So it just goes in a circle. It's just cyclical. Wouldn't that leads to star match infinitely? Technically, yes, it would. However, the databases are smart enough not to let you actually do recursive things. And so it'll find the longest path without going over. It's like the Price is Right. So this leads to star lets us match multiple things. And we can say leads to star and give it some ranges. So like 1.3 means the minimum number of hops we want needs to be at least 1 hop and no more than 3 hops. So if we have a particularly large graph, say with 1 million nodes in it, and we don't want to match, all the paths. We really only care about, things that are like within a few hops away. Then we can specify a maximum and a minimum. So this, helps. It's a performance play, right? And so you can do queries like finding all the nearby rooms. So here I want to match a room, any room, well, not any room, match the room with an ID of 1, which is where I'm at. Let's say I'm in room 1, leads to 1 or 2 away, another room, and then return the ID and name of those rooms. This will give me a list of all the rooms that are near me. So if I'm in a room, I want to say, well, what are my choices? I can go to this room and this room and this room. This will return nearby rooms. You could see how this might be useful for someone like Facebook, where they want to find like nearby, friends of friends, right? It'd be a great way to recommend friends to people. You could find, more interestingly, a nearby room with gold, right? So here I'm matching a room with an ID of 1, leads to 1 or 2 hops away, another room that contains treasure. So I've got a node leading to arbitrary number of nodes of the same type that has a particular property. So this will match every pattern in the graph, 1 or 2 away, where a room connects to a room that has treasure in it. And we can return, properties we care about. Here we're going ID, name, and gold piece value. If we order it by the gold piece value and limit it to just 1 entry back, we're going to get the room with the most gold that's nearby. So this is a way of run this query and go here, run this query and go here. Keep finding all the valuable high treasure rooms. You can query the longest path through the dungeon. This is sort of using Cypher to solve the traveling salesman problem. If I match a particular pattern, room leads to a room, I can actually match the paths as well. So in addition to matching the nodes and the relationships, this matcher will have various paths that match it, and I can assign those to a variable. So this matches every room that leads to every room in the graph, which is a lot, and assigns it to this variable p. And then I've got functions I can call on and ask questions. Like I can get the nodes that make up p. I can get the length of that path. And here I'm aliasing that length to a variable name. I'm ordering by length descending. So the biggest number gets the top, and then I can find the longest path through the dungeon to make sure I hit every single room. Fun. I can find the room with the biggest treasure. Right. Here I'm going to use a sort of aliasing, an aggregation function. So I can match all of the treasures in the database. So right here, this match max : treasure is going to match every treasure node in the graph. And then I'm going to say with max of max.gp as max GP. So this is saying with aggregate and make the max value be what you're actually returning. So this will find the value of the most expensive treasure in the dungeon. There could be a tie. Then it says, now that I've matched that, match all of the rooms that contain treasure where they have a value equal to that max GP. So in a previous match, I extracted out a variable using a grouping, and then that can be used as an aware clause for the next match. And then I return the name and the name of the treasure and the gold piece value of that item. So now I know which room has the most valuable treasure. If there was a tie, I would get 2 of them, by the way, because the where would return 2 where that was equal. I suppose I could do a limit 1 on that. So that's the room with the biggest treasure. And you can even find the shortest path to all the gold. And I've done this 2 ways. One is sort of the hard brute force way, where here we're saying match a treasure. This first line is finding out that maximum gold piece value in the dungeon, right? Match with treasure with max gold pieces, max gold piece. Match the rooms that contain a treasure where that gold piece value is at. And then here I'm giving a with here to alias the ID to a destination. This is the room I want to go to. And then I use that room where I want to go to, and the room that I'm in, which is room 1, hard-coded in the query and saying, match a pattern where the start room leads to the stop room, where the start room is room 1, where I'm at, and the stop room is destination ID. So I'm going through and I'm saying, I want to go from the room with I'm in to the room with the most treasure, and give me all the patterns that match that. And then I can return all the nodes that make up those the matched patterns. So that'd be all the paths to the database that would take me from room 1 to the room with the most treasure. And the length, I can order that ascending, which will put the shortest one at the top, and then limit 1, and that'll give me the path, the shortest path to the gold, to the biggest treasure in the dungeon, which is kind of a powerful little query. I've got another version of this, which is actually a little cleaner, because instead of saying, matching that query, we have an algorithm that will do that for us. So I'm kind of just brute forcing it in that example there, but if I use the algorithm, it's faster, right? This is a performance play. This is the same query as before. I'm matching the treasure. I'm figuring out which room is my destination. But then here I want to match just that start room and that stop room, where the start room is 1 and the stop room is the destination ID. So I'm getting just a start and a stop room. And then in the return statement, I can call the shortest path function and pass that a query, a matcher, using these variables of start and stop. And it will find the shortest path and return information about it. So that's a lot of syntax, isn't it? Let's do a demo. I want to show you that this is real stuff. I've got about 10 minutes left, I think. So I've got a little tool here that I've written that generates random dungeons. You can go check it out on GitHub. We're not going to look at the code too closely. I've got a little class called Rando, which picks random things, and I generate random rooms using a bunch of random name generators and stuff. And so if, and I've ran this earlier. So if I go into here and say, match D:dungeon, return D, that's going to return the dungeon node. I've got in my code here, and not in my samples of my slides, but in my code here, I have a dungeon node, which is sort of the entrance and exit to the dungeon. And so if we zoom in on this guy here, I've got a dungeon called the Deep Keep of Yashgalaka or something, right? And if I double click on this here in Redis Graph or in Redis Insights, I can see that it has an entrance that leads to the big chamber and the red chamber. And the exit is from Painted Pit. And if I go into the red chamber, I can see it leads to the cavernous hall, the abandoned pit, the black den, and it contains some treasure. It contains, some monsters. It contains Mormorias, the ogre, and 2 Ettins. So totally randomized here. So let's go ahead and let's create a new dungeon. Just do npm start. This just will kick off my little process. We've generated a whole new dungeon. And now if I run that same query again, you can see my dungeon is now the shattered tower of something, right? And it leads to the Blackberry. So we've got this dungeon randomizer. And we can do some of these queries against it. Let's do sort of the select star from table version of the query. Match n from match n, return n. So this matches all nodes regardless of label and returns them, right? So, and it gives us a nice little pretty format here. Here's our dungeon. There's the shattered tower of Adstromanthus, I guess. Easy for me to say. And you can look at this as a table as well. And here's a list of all the nodes that make up that this thing here. Actually, there's 10 of them, and then we can paginate through them. There are a couple of rust monsters there. A +2 halberd worth 50 gold, 40 gold, 400 gold pieces, right? So, and you can do matches like match r:room, return r, and that's going to give us all of our rooms and their relationships. If I go into a tabular view, we can see here's a list of all the rooms. We can do match a room that contains a monster. And then let's just return the R and M, the room and the monster. This will give us every room that contains a monster. Go here to a list. We can see the abandoned bridge has 2 rust monsters and 5 goblins. The big stairs has a lot of stuff, actually. A Zorn, a Ghast, and a Goblin. So these are some basic queries, but let's try some of these big beefy queries that I was showing you earlier. And I've got these canned and ready to go. So like this is going to match all the treasure, match all the treasures in the rooms. Let's find the longest path. This is by far the slowest running query of them all. And we'll see if this kills my machine or not. So this is going to match the dungeon, has an entrance of room, leads to star, n number of rooms, has an exit dungeon. So into the dungeon, through all the rooms and out. Returns nodes, the relationships and the length, order limit by 1. So here we go. We're running our query. And this is a pretty intensive query. You're literally matching every single path in the graph, right? So it's asking a lot. And there we go. It's finished. If I look at this here, I can see that there are 21 nodes in that path. Starting with, that's the dungeon. 0 is the dungeon. And then down here is the dungeon again. And these are all the nodes taking us there. So pretty cool. Let's take a look at the shortest path in the most gold. And we're going to do the slow and efficient one right here. This is the one where I'm doing it manually. 1, 2, 3. It's not too bad. Looks like the path is going from room 1, room 2, room 3, and then here's the 4th room. So 4 hops. Let's run that same one using this shortest path code. This is the same query that we had in our slide earlier. We're matching the treasure. That returned a lot faster, didn't it? That returned almost immediately. And it's given the same results, except actually the tabular output is a little nicer. The shortest path returns all the nodes and all the edges that make it up. So sitting here saying node 1 is, let's look at the properties here. The abandoned bridge, and then the painted bridge, and then the red den, and then the dank hall. The dank hall apparently is where all the dank stuff is at. So cool. That's pretty much my demo. Practical applications. I kind of touched on some of these earlier. You've got social networks. I mean, obviously, there's a social graph that would represent this really well. Bhaskar and I follow each other on Twitter, or we're friends on Facebook, that sort of thing. You've got genealogy, which is sort of a social graph over time, where so-and-so beget so-and-so beget so-and-so. Got transportation networks. These are natural graphs where you've got like bus stops and train stations and the connections between them. And you've got logistics networks, like the example one of my coworkers used, a former coworker, was that of finding out where the bad spinach comes from. And so we've got a graph that represents the farms and the trucks and the warehouses and the stores and the people who get the food poisoning, right? And so you can say, well, people got food poisoning from these 3 stores. These stores got all their spinach, and oh, look, it only tracks back to this one farm, that sort of stuff. So graphs are great for those sorts of queries. They're great for those recursive relationships that are the relational databases that don't do very well. Some resources to check out if you want to learn more about graph databases. Obviously, I think Redis Graph is the best graph database of all the graph databases out there, and I'm totally biased because I work for Redis. But you should go check it out. It's a free and easy one to get up and running with. If you want to learn more about it, you can go to redisgraph.io. We've got a Docker image out there that we use, and there's a reference to that in my code as well. If you want to learn more about the Cypher query language, that was created by Neo4j, who, in all fairness, really is the 500-pound gorilla of in the graph database space. They created the Cypher query language that I taught you today, and they use it in their products. So you can check out their stuff. You can check out OpenCypher. Neo4j is a very complete implementation of a graph database. Redis Graph actually has the benefit of being in memory and using some newer ways of querying, and so it does win in the speed category. So depends on what you're trying to do. And I've got a blog post I wrote about Redis Graph as well. It might be worth checking out. If you want to not write all those URLs down, you can just scan this QR code, which will never give you up nor let you down. It will take you to my GitHub repository, and you can get the slides and all these links and get all the code that I just showed you and everything that you need. I got a little Docker Compose that will let you run these queries and everything. So check out that URL, github.com/GuyRoyse/D&D and graph databases. And I work for Redis. We've got a Discord server, a YouTube channel, and that you should check out. I actually am the admin for the Discord channel. So yeah, and I'm on there a lot. So if you got questions, you can always find me there. YouTube, we've got a whole bunch of YouTube videos on lots of different topics. And I'm in some of those as well. So go check those out. And perhaps the easiest way, I'm using a Docker image because it's conference talks. There's the Wi-Fi thing. Now I'm on my own Wi-Fi and I'm virtual. So my Wi-Fi is reliable, but you can get this up and running very quickly with a Redis cloud account. Just go to redis.com/Redis Enterprise Cloud. You can get a free tier and get a graph database up and running just by logging in and creating an account. And so that's a really easy way to get it up and running. So that's pretty much what I got. My name is Guy Royse, developer advocate at Redis. Give me a follow. There's my link to my GitHub. That's all I got. If there's any questions, I can take those real quick. Otherwise, I'm going to wrap it up. Thanks.
Oops. So I just learned that I'm live. Hello, netizens. I'm William. I am a developer advocate for OneSignal, and I'm going to be presenting a talk on how to improve your engagement on your site that's built with React. We're going to talk about a few things. Most of this is what I would consider mostly common knowledge, but maybe some of these things are items that you haven't thought of yet or that you haven't done yet. So we'll start off with some of the things that you could do to improve your site. Number one is load times. When you're dealing with a customer, they tend to want to get to your site as quickly as possible. And the quickest way to lose them is to have your site take a little bit too long to load. So we'll talk about that. We'll also talk about responsiveness. You want your website to work on this device right here because a lot of people are using these nowadays. And finally, we'll talk about how to make contact with your customers in order to increase engagement. So we'll jump into load times. Oops. Sorry about that. Of course. All right, so first thing that you could do is make your website fast. The reason behind this is that the optimal load time for most sites across all of the internet is 700 milliseconds to about 1.2 seconds. And this is before people decide to leave your site. So you don't really have much time to make a great impression. And the best way to increase the speed of your site is to go on a bit of a diet. Your bundle size that you're shipping to your clients, they tend to be fairly large and block the rendering engine from actually rendering out your page. So you want to make sure that your JavaScript file is as small as possible. There are some ways that you can do that. The most obvious one is to remove unnecessary packages. Think about your favorite libraries. Let's say an animation library. How big is that library? If you are using just a few animations, you're shipping an entire framework or entire library to your client just to enable that. Maybe it's not needed. It's probably not attributing to the bottom line of your product. So probably get rid of it. Next is tree shaking. Tree shaking is removing dead code. And dead code in this case just means code that is in your code base, but it's not being used anywhere. And it makes sense to remove that code out of your application when you're shipping it to your client, because if they're not going to use it, it doesn't make sense to use that bandwidth. So you can do this with Webpack using this particular optimization here called use exports. And I'm just setting that to false, and that will make sure that whenever we bundle our application, code that's not used anywhere else in our app will get thrown out. Next thing we can do is code splitting. And this involves splitting your bundle up into multiple pieces. Maybe you don't need every piece of functionality at the time your site loads. And code splitting is a useful way of accomplishing like having a deferred loading strategy. Here's an example of how you can do that in Webpack. So here, I don't have a laser pointer, sorry for this, but on right where it says entry, we have two keys. We have index and we have another. Another is just another bundle that we can name whatever we like. It could be an ES module, and we can load that thing in dynamically. Next is avoiding CSS libraries. These things are quite useful in helping you build your application in record speed, but they don't allow you to load your application in record speed. You may want to get rid of them. So let's get rid of all of these. Okay. Is my computer freezing again? Sorry, my computer's freezing. Okay, there we go. Okay, all right, so finally. All right, so avoid using all of your CSS libraries, just use CSS. Remember, CSS is awesome. It won't be that bad. And the reason behind using this, come on, catch up. Sorry, my computer's freezing again. And the reason that you want to avoid using these CSS libraries is because they're quite heavy. Notice here that one of the bigger ones is Tailwind CSS, clocking in at 289 kilobytes. This is a bit of a lie, mainly because with Tailwind CSS, you can prune out unused styles. So this would probably be closer to 3 or 4 kilobytes. But as you can see, all of these CSS libraries or frameworks, they all add quite a bit of heft to your bundle. And you also want to use regular CSS because if you're shipping CSS in your JavaScript, you're not going to be able to like get rid of it. Just think about it this way. In order to ship CSS in JavaScript, you need to write JavaScript, which means that you're shipping it across the wire. Okay. The next strategy that you could adopt is laziness. And this is just loading stuff when you need it. You probably don't need to load every single page in your application right when the user logs onto your site. Chances are you can defer some of that loading until you absolutely need it. And the way that we can do this is we can query a function where in this case, I'm creating a function called load, and that's going to return a function that accepts a component, which will then return another function that accepts props. And this allows us to defer the loading of our component until it's absolutely needed using React's lazy function here, where I'm doing load, lazy, and then I'm just importing some page. And this works very well with code splitting. So these kind of go hand in hand. Okay. The next thing that you should do is make your site responsive. It has to work on a phone. Half of all consumers, they browse the internet from a phone. And 1 in every 5 transactions is completed on a phone. So it probably should work on a phone if you want to make sure that people are as engaged with your site as possible. There are about 4.3 billion people on the planet, and they all access the internet from their phone. That's a really large number. Just to give a little thought exercise, that 0.32 right there, that represents about 320 million. That's about the size of the United States of America. There are a lot of people who use their phone almost exclusively to browse the internet, so you want to make sure that your site works for them. 54% of internet traffic originates from mobile devices. So you really want to make sure that you're building stuff with them in mind because they represent over half of your customers. But don't forget that regular devices need love too. These are your desktop computers, laptop computers, and for those of you who are fortunate, extra large monitors represent another class of devices. You can make your site responsive by using a library. In this case, I am recommending React Responsive. It allows you to integrate their stuff using hooks so that you can set up a particular type of query and you can just ask, like, are we on this type of device? Like here, where it's like, is desktop or laptop? If so, we'll just render out you're on a desktop or a laptop. It makes it incredibly simple, and you don't have to create your own custom hooks in order to listen to events to understand how big your window is. Okay. And then also want to make it accessible, you know, or you can go to prison. And seriously, you can go to prison, but it's probably not that likely. There was a case where Domino's basically got sued by someone who was unable to order food from their website. So it turns out that if you have a physical location, that your website also has to be accessible so that you can avoid getting sued. So you can use UI toolkits like Chakra in order to kind of help with the accessibility of your app. You know, you can have accessible UI components along with you know, the colorways and all that kind of stuff. Okay. Next, you need to know your customer. You want to take things slow at first, right? First, you ask for their email. Then you want to ramp it up a notch and then ask for their phone number. Once you have this information, you want to make your first move. Well, in this case, we're going to be talking about push notifications. But if you're using OneSignal, you can actually deliver messages however your customer likes. But maybe you're shy, or maybe you're lazy, or you're just busy. Whatever the case, you know, OneSignal, we have your back. We do push notifications, email, text messages, and in-app messages. So I'll do a little bit of an explainer about each of these. Push notifications, those are what most people are familiar with on a phone, but we also support web notifications where we will put a notification using your browser, and they can be displayed natively or using your browser's framework. Emails, just that, we allow you to send messages to your customer via emails or text messages. And an in-app message is if you had a mobile app, you're able to actually message a customer from within the app. That's it. So with that, we'll kind of go into a demo. This may work. Sometimes these things don't work. There is a sample project on GitHub. You can access that sample project by taking a picture of that QR code. And on that website, there's also a link to a blog post that goes over all of what I'm about to go into in detail. I'm gonna leave this up for about 10 more seconds, just in case anyone wants to copy that. All right. So with that, we're going to jump into a demo. So in this demo, I'm using something called Next.js. Maybe you've heard of it. I'm using this because it does a lot of the things that I mentioned earlier for me, like code splitting or removing dead code, tree shaking. And it allows me to create a React app without much effort, which I am a huge fan of. So let's kind of get started here. Right away, you can see that I am importing something called use OneSignal. This is a custom hook that I developed where all it is I'm initializing the OneSignal SDK, which I have imported into this project, and I will walk through how I imported that in a moment. But as you see, all I'm doing is I'm setting a function that I want to happen whenever push is called. In this case, I want to initialize the application, and I want to make sure that I'm allowing localhost as secure origin. In this case, it's because I'm giving this demo, and I want to be able to make sure that this works on my local machine. So that's all that's really necessary in order to get OneSignal integrated into your app, other than adding 2 web workers, which you can get these from our documentation, or you can just copy these like so, where it's just pointing to where they're located. So let's go ahead and get this app ID, and we're going to create a OneSignal app. All right. Just log into the dashboard here. And I have this pre-existing OneSignal app. for Next.js, but I'm going to create a new one. And I'm going to call this JS and Friends. Won't make it belong to any organization. I'm going to select a platform that I'm trying to work with. In this case, it's web. And I'm going to give my site a name. So this is just JS and Friends. My website is going to be localhost. I'm just going to copy that from here. And I want to make sure I copy that port so that I don't get any issues later on. All right, and we're going to enable local testing. And from here, I can save. Okay, we'll continue. We'll make that 3001. And I need to come and grab my key to fill in this app ID right here. So we'll just copy this over and we'll plug this right there. And from here, you have an app that works with OneSignal, and you can deliver push notifications by just sending a message. So we'll go ahead and save this. And we can come over to messages. And we'll select new push. But before I do that, I probably should start my app. And I want to get this started on port 3001. Or maybe I should delete the other app that I did just to test this. So I'll delete my app that I did just to test this out, because I think that's the simpler option right now. So we're going to start up the application, and I'm going to bring this over here into Chrome. Looks like I'm having an issue. Give me one moment as I try to correct this. I'm just going to use my test app. So we'll put that ID in here. Back. Oops. Let's see if we can get this to reload properly. Yes, cool. So I'm already subscribed to notifications because it understands that I've already done this with this app. So we're just gonna roll with it. So whenever you integrate with OneSignal, you're gonna get this little bell icon at the bottom of your web app. And this is what allows your customers to subscribe to your push notifications for your site. They can also unsubscribe as well, but for now, we're just gonna stay with being subscribed. Now I'm gonna come over to OneSignal. And we're going to push a new notification. So this is going to be JS and Friends. You can learn more by checking out the OneSignal blog. All right. And I'm probably going to link to something else. I'm going to actually link to our OneSignal developers URL and say you can learn more by checking out our OneSignal community page. All right. You can also give this a URL image as well. So I'm going to go ahead and look for a nice little image that I can use. So we'll bring this over here so you can all see what I'm doing. So we're going to just go to our blog. I'm just going to jack this image right here. So we'll throw that right in there. Okay. Oh, look, I already have one prepped. We'll just use the one that I have prepped. All right, so let's move this over here and let's preview and send our notification and see what happens. Ah, okay, so we got a notification. And if I click that notification, it takes me to the thing that I linked into inside of the URL here. Let me see if I can go back. Okay, yeah. So it just linked me to whatever I put here in the launch URL. So if you have users who you don't know, then this is actually a great way to just get a sense of understanding of how engaged they are. Because if they are subscribing to your notifications, that gives you a little bit of signal that they are interested in what you have to say and that you are providing value. Now, if you have user accounts, you actually have a lot more information about their user, but you can still leverage one signal to remind them about things like, say, for instance, if you're running a e-commerce site and you have a customer who has a cart and they go off to some other internet site, if they're anything like me, they're probably always browsing different tabs and all that, and they forget what's going on. You can actually use our tool in order to send them a message and say, hey, we noticed that you have a cart, would you like to complete your order? And we can do this based off of whether or not they are in a particular segment. So we do offer segmentation. And we also offer retargeting. So if someone doesn't respond to the first message, maybe you can send them another message, but on a different channel, such as email, or maybe you can text them. So this is, let me get this over here. So this is really all that you really need to do in order to increase engagement, at least in your React app. There are a lot of other things that you can do on the technical side, like improving your infrastructure. But just when it comes to React, there are a few items that you should do right away, because they have a very big impact to the size of your app, which has a very big impact on how fast it can get delivered, which also has a very big impact on whether or not someone stays on your site and does the thing that they would like, or that you would like them to do. So with that, my demo is over. So I will jump back into my presentation. All right, so you can learn more about OneSignal and how you can integrate it with your applications and see code samples and all of that kind of good stuff at the OneSignal developers community page. This link will also be available here in case you would like to go to it. You can also follow us on OneSignal Devs. This is both on Twitter and on GitHub. There you can find all kinds of posts that we make that kind of give you tips on how you can increase engagement, like this one, or other tips on how you can improve your workflow, your developer workflow. We also have our code samples hosted in GitHub, and each one of our code samples will link to associated blog posts, so you can always learn more about what we're doing there. You can also follow me. I am Will Shepherd on Instagram, Twitter, and GitHub. That concludes my talk, so I will hold the floor for questions. if y'all are still watching and wondering like why I'm confused, it's because I am trying to figure out how to interact with you all. I don't see anyone, so give me a moment and please bear with me. Slack workspace, okay. Move that to here. Okay, so I'm being told that there's a Slack workspace. Track down questions. Okay. All right, so it sounds like there are no questions, or it looks like there are no questions. So feel free to follow up either on Twitter, you can DM me there, or you can send a DM to the One Signal devs, this one right here. And yeah, I hope you all have a good rest of the day.
developer that works with images or videos in your web app? Did you know there's a global community on Discord to network with other developers that shares knowledge and best practices when it comes to working with media? Come join us and chat. In our Discord, you can find interesting stuff such as developer events others are participating in, resources and tips, career advice, best practices, tools and plugins, paid opportunities, content sharing, or even hanging out and sharing your pet photos and talking about video games while getting to know other developers. We will be raffling out weekly prizes for being an active community member. Join the server by going to this URL. See you there. Hi everyone. Are you a developer that works with images or videos in your web app? Did you know there's a global community on Discord to network with other developers that shares knowledge and best practices when it comes to working with media? Come join us and chat. In our Discord, you can find interesting stuff such as developer events others are participating in, resources and tips, career advice, best practices, tools and plugins, paid opportunities, content sharing, or even hanging out and sharing your pet photos and talking about video games while getting to know other developers. We will be raffling out weekly prizes for being an active community member. Join the server by going to this URL. See you there. Hi everyone. Are you a developer that works with images or videos in your web app? Did you know there's a global community on Discord to network with other developers that shares knowledge and best practices when it comes to working with media? Come join us and chat. In our Discord, you can find interesting stuff such as
Thank you all for joining us at this year's JavaScript and Friends Conference 2021. We hope you had some nice, insightful talks from all our awesome speakers today. Thanks for speaking with us today, friends. And with that said, we would like to thank all our sponsors. Without your support, this event would not be possible. So thanks again. Thank you for sponsoring us. And I would like to thank our community friends who all have supported us today. So thank you, Auth0, Scout APM, Cloudinary, Doherty Business Solutions, Leading Edge, and thanks to Improving, LifeRaft, Nasr Press, OneSignal, Thunkable, and Couchbase. And we thank all our developer community friends, and we thank all our speakers. And once again, thank you, Matt, and thanks, Barrett, and thanks, George, for selecting the content. So whatever talk which we saw today, it's all selected by them. Thank you for being with me and helping me out every year. Thanks again, and thanks to Brandon for running our operations. And thanks to all our volunteers. If you are interested in helping us out in any way, you're always welcome to reach out to us, and we are happy to take in volunteers. We look forward to see you all again next year, 2022, and hopefully it will be in person and things would be developed or things would be changed by that time. So we hope to meet all in person next year. Follow our Twitter and LinkedIn so that you will get updates. And with that said, we will send feedback forms. Feel free to send in your feedback, and we will be selecting the feedbacks from our Slack channel as well in Conference 2021 feedback channel. So please share your feedback. We'll be selecting two users from the feedbacks, and you will be getting an opportunity to win a swag from Nasr Press. And so go ahead and send in your feedback in Conference 2021 feedback channel. So thank you all again, and thanks for hanging around. Thank you. Hey, Brandon, thanks for joining. You're welcome to share in your closing thoughts as well.
Thanks. Apologies, my dogs are in the background and they're very excited for some reason.
Yeah. If you have any closing thoughts, you can share them. And
yeah. So I just want to hop on and say thanks everybody for joining. Obviously, it's been a hard year and a half, 2 years now for everybody, but this year was tough with having to switch around all of our plans and stuff. So we just thank everybody for sticking out with us and for supporting us. We wouldn't be here without you guys, and we hope that you guys got a lot out of this, and you continue to stick with us in the future and get even more awesome content and such. So, and big thanks to Bhaskar for running all the technical stuff and getting everybody up and running. Couldn't do it without him. So thanks. It's been awesome.
Awesome. All right. Yep. We will meet you all next year, friends. Thank you all.